It's come to our attention you have the Minecraft map up?
I don't know what you're talking about.
This is not a Minecraft stream anymore, sir. This is a Space News stream.
Come here, you can look. She's still talking in the other room to herself. What can of worms did I open here? Jesus Christ. Okay. I'm going to take 5. I'll switch this over to Space News, and we'll go from there. And then we should have KSP on the other side. You're marrying her? Yeah. Yep. I honestly appreciate how seriously she's taking her job. If you got a job, you better do it well. Right? Okay. Let me get a video up for you guys. Alright. I'm going to show more of that Pima stuff if you guys don't mind. Yeah, here we go. Even though I just really hate hearing my voice. Alright.
How are you?
Here we go.
Welcome to day 4 of Vector's virtual field trip here in Tucson.
I'll be back.
So, if you remember, we went to Pima on Thursday, and then we did Space Fest for 2 days. Space Fest is pretty much packing up now. The last day is really kind of just the wind down day. Not really many people are going to be there, so we decided to come back. To Pima. I mean, hey, lonely guy with the 34-month resub. Thanks, man. We decided to come back to Pima because, I mean, we didn't get all the museum last time, Saber. Nope. No, we didn't get all of it. We got, I don't know, I'd say like half. About half, yeah. Half of this place. We got half. So, I figure let's just go around the horn again and look at some really awesome planes and really awesome helicopters. So, I mean, I thought that this might be the right place to start. Hey, William, how are you? I thought that this might be the right place to start here. So what we have here...
No, you don't have to be close. You just have to face the camera when you're talking.
What? What are you talking about?
Yeah, exactly.
Huh? So we have an Mi-24 Hind right here. This is a Hind D variant. You can tell it's the Delta variant because of the bubble canopies. The earlier versions of the Hind had this huge kind of, looked like a big bay window on the front, but this one is the newer version. This is a newer variant. This is a Russian attack helicopter. But here's the thing: it's not really an attack helicopter. It's like halfway in between. The Hind's good time zone. Yeah. Don't forget the space stuff. Don't forget the space stuff. Really? The Hinds are actually a combination of a transport helicopter and an attack helicopter. It's like if you took an Apache and a Huey and kind of rolled them up into one. It's a very interesting design because over here we kind of separate it out a little bit. There's like, we have our transport helicopters and then we have our attack helicopters. They usually have designated roles. The Russians are just like, nah, niet, comrade. Combine them into one thing. So that's how you get this big honking helicopter. If you look, like, you got a pilot, you got a gunner right there, but you also have a hatch that can hold up to eight fully loaded troops. It's pretty good, right? But the Hind also has a lot of room for explodey bits, physics packages as we call them, kinetic energy experiments. I mean, it is an absolute beast of a helicopter. I mean, look at, and this is just one side. You can have this all on the other side. You can have anything from You can have air-to-ground missiles, and like traditionally, I've seen most Hinds have like rocket pods here. So just unguided rockets. It's like an Estes rocket with an explosive on the front. You think 8 EJ-sized people can live? It can fit in these hatches? It'd be tight. It'd be a tight squeeze. Hey, Creeper, what's up, man? How are you? But yeah, I mean, maybe not 8 of me or Saber. Maybe like, I don't know. I'm trying to come up with a good analogy, but I was gonna say maybe 8 DOS-sized people.
He's not that much shorter than us, though. That's the funny part. It's like people are always like, "Oh man, you're shorter than I thought you would be." And like if it's just both of us next to him, it's like it's just because of these two. Sorry, DOS.
Sorry, DOS. Ozzy, what's going on? So another cool thing about Hinds is that it looks like it's got a wing here. The pylon mounts are on a wing, and the reason is because this thing could carry so much payload. You can fit so much payload in this bad boy. The reason it has this wing here is because it's designed to take blade load off of the blades when the Hind is actually moving through the air. These actually work like wings. They take a little bit of load off the blades so you don't rip that complicated piece of equipment apart up there. I mean, you know we like swash plates and helicopters on the stream, but geez, look at that thing. Maybe we should go to the other side where the sun isn't in the lens.
Sorry. I zoomed in on just the swash plate.
That is, I mean, can you imagine? Look at all those rotating parts up there. Like, all those things are spinning at crazy high RPM. Like, probably, I don't know, with a helicopter like this with these blades, it's probably not above 1,000 revs per minute, but it's still up there. Hey, Jazos, what's going on? How are you? Look at those things. So, I mean, you got your swash plate there. That's the bright part, the bright aluminum part at the bottom, and then you have your links up to the blades, and the blades actually can. That's what it makes the blades pitch, and then you can see the actuators popping out. It's a ball joint that's attached to the bottom of the aluminum right there. Can we see the F4 today? We're here the whole day, Ozzy. We're here the whole day. So we're going through the stuff that we kind of went through quickly, because last time when we were here on Thursday, we kind of blazed through this stuff a little bit faster because the museum was closing. But we're going to try to hit everything in one day. It's going to be a lot of work. But Saber, are you prepared?
I'm prepared, yeah.
Yeah?
Yeah.
DC3 girl, are you prepared?
I'm ready.
She said she's ready. Okay, so I'm ready. I'm ready. Okay. I won't do that again. So 5,000 rev helicopter on Earth, the Mars copter is going to rev at 25,000. That's insane.
Well, there's also a lot less atmosphere on Mars.
Yeah, I mean you're gonna need them revs. So the Hind's a pretty big helicopter, but also there's a wild cat over there.
I mean,
we could.
Not a wildcat as in wildcat, but a wild.
No, just
Wild
a
space cat,
feral,
yeah.
feral cat. house
Feral cat? I mean,
I don't know.
we could
It may not even be feral.
We could go get some fish and then we could capture it. We could use it to keep the creepers away.
Sure. So I've heard of barn cats. I've never heard of boneyard cats, I guess.
But I guess they'd be a thing.
I mean, this isn't technically the boneyard, but
Yeah. Anyway, so the Hind is a big helicopter, but we're gonna go look at this one. We saw this a little bit earlier before, but I just wanted to touch base on how big this thing actually is. I mean, this thing is about as close as you. I mean, it's literally a flying school bus. These things are basically designed to just. I mean, this one is an MH-53, so it's a Navy one, or Marines. Marines would use this. Basically to send guys out on an extremely long range. Part of like what the Pavilion has is it has ridiculously big extra fuel tanks on it. I mean, and this is a big helicopter. It's not the biggest helicopter around, but it's about the same size. I mean, a Chinook's about the same size as this, but I mean, this thing, the Chinook has 2 rotors. This thing has one big boy rotor up the top. Look at that thing. I mean, and on top of that, Pavelos also have. They also have aerial refueling capability. You can refuel these off of, I think they use KC-130s or maybe a V-22 variant or something later. Probably somebody knows. Do you know exactly why there was no Apollo 18? Money? That's a long story, dude. Hey, Wirelord, what's up? The monster can hold 40 EJs. Here, let's go see if we can look at the cargo bay. I mean, actually, Chad, I have a question for you. I don't necessarily know this. This conic-shaped intake on the front, is that some type of, it's got to be like a pre-cooler or like an intercooler or something? Like, is that to Is that to like charge cool the air? Like, why does it have the intake like that? Is that the radome in the front? I think so, yeah. I think so, but I've always wondered that. I never actually bothered to actually go and ask. It's for dust creeper? You would know. Just dust guards? Yeah, that makes sense. Air filter, similar to the CV22. Gotcha. I mean, isn't that that's what replaced this? MH53s were replaced by MV22s. Added due to Desert Storm. There you go. So, of course, you have detachable fuel tanks here, and ideally you wouldn't want to jettison one of these things, but if they needed to for the mission, they could. But, I mean, you can tell that this could be jettisoned because it has the stabilizers on the back. But man, that's a big freaking fuel tank, dude. Okay, rated for dust. That's crazy. I mean, look at the cargo hold on this thing. This thing's out. It's locked. That'd be awesome if we could go inside, but I mean, it's, you know, people say like, oh, it's about the size of a school. This thing literally is about the size of a Greyhound bus. It's pretty big. Engine intake barrier filter. Thank you, sir. Cool. All right. So, horsepower? All right. So we could go look over here. This is another helicopter that I don't know much about. We looked at it real quick last time, but it's on the opposite side of the hind over here. The size of a semi-truck with a trailer? Yeah, it's about that size. It's pretty big, man. It's a big helicopter. I mean, the hind is huge. The hind is as big as the Pavilion, and that's something I didn't expect. I never actually thought I would be standing next to a Hind D. This is an awesome helicopter. I love Hinds. Hinds are my favorite. Just because it's ridiculous and I love it. We need a Pavilion for Kerbal Career Ops. Dude, you imagine making that? I mean, we could. People have done it. Raid, you've done it. I know you can make that, but geez, this thing is, I mean, I don't see why I'd need a Hind so much. I'd take the Pavilion. I don't need the weapons. I don't need the kinetic energy experiments. That's fine. Footage from Apollo 17 is much more colorful. Now, chat, maybe you can tell me about this. This was, I guess, an experimental helicopter. Maybe you can tell me about it. This is an experimental helicopter. I wasn't familiar with this until we saw it on Thursday. I didn't even know this thing existed. I mean, it is a strange looking helicopter. It's a C-37 Mojave heavy assault helicopter. This kind of looks like it was kind of like maybe an intermediary between like the Pavilion and this. This looks like it was trying to do what the Pavilion was doing, but they didn't have it quite figured out yet. Let me take a look. What do we have in here? So there's definitely a radiator here. And is that a radial engine? It might. Yeah, no, it looks like it. So this thing has like bomber engines in it. I mean, but then again, they didn't really understand that you could use a jet engine for shaft horsepower. Also, police cars. I'm trying to look and see. It definitely has the exhaust that look like it's a radial engine, but I mean, look at this long freaking landing gear, man. This looks like landing gear out of the space shuttle almost, which is funny because it's not even the right year, not even the right decade. It is a CH-37, yeah. Dude, I'll be honest, guys, I didn't know what this thing was. I'm like, I straight up don't know what this is, but I'm learning, and that's why I have you guys here with me. If I don't know something, you guys got my back, and I appreciate that. But, I mean, it's funny, like what I was saying, you see like the meta, like they were trying to figure out how you could get a lot of cargo in this thing without compromising structural integrity in the tail or in the front. So they have this like ridiculous cargo door in the front. Look at this thing. It's a big old cargo door, and the front looks like the front of this thing looks like a train. It looks like a freaking train, man. That's ridiculous. You see the intakes, but oh, wait, Saber, look at this. Look at that. See that right there?
Oh, yeah.
Is that the drive shaft? Is that the drive shaft?
Yeah, you got to take that into the rotors.
Yeah,
So
it
you
has to
gotta
be a
take it.
gearbox in it. Look
Yep.
at you can see the drive shaft sticking out.
Mhm.
I'm not sure if DC3 Girl remembers because it was hidden round back, but there's one of these at Evergreen too.
Yeah, that's what I wondered if it was the same one.
Yeah.
Mm.
Look, this one's name.
what's its name?
It's us last night.
The tired dude.
Yeah.
Yep.
It's a weird, I mean, it's a weird design, but this is a very early helicopter. They still didn't really have it figured out yet. So what's the orientation of the engine? I'm not 100% on that one. It looks like they're transverse. The engine, you can kind of see it, but it looks like the engine is this way. It's mounted this way going that way because it's got to line up with the drive shaft to some extent. I almost took a digger, but that wasn't on camera. That's
No, it wasn't. You're good.
all right, no, it doesn't matter. It looks like they're mounted at an angle almost. I'm looking up in it. Yeah, no, I can see it in here. I don't think the camera will be able to get that, but the engine is like this. It's kind of like offset at 45 degrees so that the drive shaft goes in that way. Are those bullet holes? I highly doubt that.
No, I don't think so.
I don't think these things ever saw combat at all. But I could be wrong. I didn't know anything about the helicopter in general. Crazy design. But see, like, they have the external drop tanks, like, just like the Pavilion does. So the ideas were there, but they didn't really have it figured out yet. So let's make our way to this guy. Speaking of big helicopters, look at this one. Who knows what this is? How's the weather down here? Yes, warm,
Yes.
warm, very warm. We are weathering right now. 4 CH-37Bs were deployed to Vietnam in 1963 to assist in the recovery of downed U.S. aircraft. Per Wikipedia, nice. The crazy thing about the CH-54 is that they wanted to use this thing to do all just like as bare bones, like use as much for lifting purposes as possible. So there's no like cowls, there's no fairings up there. You can just straight up see the engine and the gearbox, and you can even see the drive shaft going to the tail rotor right there. It's all just sticking out. All the guts are just kind of hanging out on the side. Reminds me of a grasshopper. Yeah, I mean, this thing is basically, I mean, it's a CH-54 sky crane, right?
Yeah.
But that's what it is. It is a sky crane. Like if we come down here, you can see the crane. Right here, there's the main boom. And it's just on a winch, and this is, the cool thing about this is that this would be on the center of mass of the helicopter. This is the exact center of mass. I mean, you don't want to pick up something back there and have the thing whoop. And then to make sure that they centered the payload, they have these auxiliary winches over here at 4 corners that are equidistant from the center to make sure that stuff stays right in the center. So space engineers designed this. Sikorsky did. I mean, helicopters are complicated, man.
Sikorsky has a little bit of experience with helicopters.
Yeah.
Just a little bit.
Is that a McCullough MC4 behind you? Maybe.
Maybe.
Maybe not. No. I mean, we're going to go a little bit slower this time around than we did last time, so I want to take a little bit more time with each plane because we have more time. But if you look at this area right here is they basically took the controls from a tower crane and just put it right here. They put it on this part of the helicopter, the back of the cockpit. And then this is how you get in right here. This is basically a tower crane operator. There's a guy sitting in a seat right here, and he needs a big canopy or bubble cockpit so he can kind of look over and also be able to look down, because crane, pick things up. Build one in KSP. Oh, I'd do it. We could do it nowadays, man. But we don't have a winch. That's the thing. There's no cables in KSP.
Well, and one of the cool things about the controls back here that the operator would be using is that they actually have, I forget what percentage it is, but some minute percentage of control over the entire helicopter's motion.
Yeah.
But it's a lot more subtle. It's not like full forward to be a full pitch forward move. So they can actually sort of use that to help line up.
Fine control.
Yeah,
okay.
exactly.
So yeah, that affects the swatch. Can you imagine how complicated that actually is? A helicopter that can be controlled from 2 different points. That's a little. I'm gonna go with yes in terms of complication levels. How complicated is it? Yes. Also needs viability for signaling from the ground crew. Yep, there you go. Can we go back and look. You guys see those bars that are going on the side of the helicopter? You know what those are, right? You know what those are? Saber, do you know what those are?
Yeah, man, those are the control linkages
Yeah.
for controlling
That's
the
the
aircraft.
control linkages
Yeah.
for the swash plate.
It's funny seeing all this stuff external because
Yeah.
on most helicopters it's internal.
Yeah, you
like
wouldn't
even
want
the drive
that.
shaft and stuff.
Yeah, you wouldn't want that on the outside.
Yeah.
But, I mean, the turbo shaft is just right there.
Yeah.
Just right there. That's the, yeah, those are the flight controls.
Mhm.
Those are the linkages.
Yep.
It's ridiculous. They're just there. Unbelievable. Can we let's go look at the what is this fit? Yeah, go look at the front. The front generally looks like a run-of-the-mill helicopter, right? But look at it from the back. Oh my. It is not the same. It is yes degrees right now. Yep. Is there two? There's got to be two turbo shafts up there. Yeah, there is. There's two of them.
Yeah.
Jeez. All right. I mean, it's so utilitarian, this thing. It's just like, nah. Yeah, it's not gonna see combat. Just leave the stuff on the outside. It makes it lighter. Yeah. Yeah, I mean, I'm like a kid in a candy store here right now, I'm not gonna lie. But I have to come back, but I got sidetracked by Hoot Gibson. Talked for an hour and a half with the guy and he gave me his card and autograph, picture for free. Nice. Yeah, Hoot's the man. I have his signature too, dude. He's pretty cool. He's got an awesome mustache. Mustache game on point. Here, let's go down the list here. I mean, Saber, see if we can take a pan shot and look at all the helicopters that are here, man. Hasu, what does the sky crane usually lift? Anything. I mean, anything that the Army needed to be moved around. Oh, we have a Humvee here, and we need to put it up on top of that hill. All right, sky crane. Artillery pieces, even some light tanks. I'm pretty sure the sky crane can lift a Sheridan tank. All right, let's start, I guess, with this one. Start at the top. Did he know who you are? I didn't get the chance to meet him. Shame. So the early helicopters I don't know too much about, but it's just a Sikorsky Hg5. You can still kind of see that they were kind of figuring this stuff out. They really didn't have the helicopter game on point until a little bit later. This is kind of a weird setup, that's for sure. What's powering this? This has got to have a bomber engine in it or something. Here, I'm going to take a look. Well, it looks like this one's running on hopes and dreams. We got no engines, Ted.
It's doing better than this one.
Yeah. Yeah, this is the stealth helicopter.
Wonder Woman's airplane.
Yeah, this is the prototype stealth helicopter right here, look. It fits so much stealth in this bad boy. Let's go back. Yeah, there's no engine in this thing. There's nothing in there. Yeah, it's just the frame and that's about it. I don't know. It looks like a radial engine would be in this thing though. Yeah. Interesting. Why are they hiding the windows? That's a good question. They hide the windows because these windows are all like plexiglass. They're not like real glass. I mean, real glass is too heavy. It's all plastic, but they paint over them so they don't get wrecked by the sun, so they don't get oxidized, because the sun damages things. Wear sunscreen. That's basically these things' sunscreen. Don't paint yourself and expect it to be sunscreen. Anyway, so what about this guy? What is this one? It looks kind of like a Bell 47, but Bell HTL7 Sioux Trainer helicopter. Let's see what do we got here? Oh, huh. A Lycoming Flat 6. Look at that. Piston. There's more on the other side. Look at that thing. I mean, talk about exposing the guts.
He said
Like,
moron.
all right, you gotta make it light as possible. Don't need cowlings, whatever. I want to paint them, girl. Life hack. I mean, these early helicopters are something like they didn't really figure out that you could use a turbo shaft until a little bit later. So these things were using off-the-shelf stuff. Like that's an airplane engine. Like for, I mean, I don't know what that Lycoming 6 will be out of, but I bet you it's like out of not a Cessna, but something like that, something like a little propeller plane. They're just like, oh, why don't we just take the propeller engine and put it over here and make it facing straight up? It's crazy.
One little marquee there.
Yeah. Why don't we just take this helicopter engine and combine it with a Patrick meme? What? So, actually, another thing that I wanted to that you look at, because this thing has the guts exposed, is the fact that it has the way the gearbox is it has two outputs. So you're taking like this is where on a propeller plane there'd just be a propeller engine or a reduction gear here. But if you look, the main rotor goes up. The engine's on the main rotor. But if you look, see that spline hole right there? That's the drive shaft to the tail. And you can see because it lines up with the actual drive shaft. This thing right here would be spinning.
It's called an output shaft, EJ.
When the helicopter's on.
Spline hole. Output shaft.
There's carrier bearings there.
Output shaft.
It would go all the way back into a little teeny boy gearbox right here, right? And then these cables right here are the control surfaces for yaw control in a helicopter. And it would turn these blades. See, there's a linkage.
Dude, I hate hearing my voice. I'm not even kidding. I freaking can't stand it. I hate hearing my voice. I can't do it. This is like pulling teeth right now. Ugh. 2 EJs. That's right. That's the before times, EJ. I hate hearing your voice as well, too, to be honest. And why you here?
I'm not sure, George. I'm not sure.
Guys, that space shuttle thing that's in the background is the space pavilion. This is something that we really didn't get to go into. We ran out of time. I ran out of time for the space pavilion. I don't know how that happened, but yeah, we ran out of time. I walked into the space pavilion real quick and talked to the guys in there, and I was looking at a motor. They're like, yeah, it's a rocket engine. I go, it's from an SM-65, right? And he's like, how the hell do you know that? I'm like, oh boy. Yeah, everything. No. It's normal to not like your recorded voice. It just sounds so freaking nasally and sound like such a tool. But then again, I kind of am, so it kind of works out.
I don't know much about the early helicopters.
Yeah, I still don't. This helicopter, for whatever reason, I always forget the name of. I don't know what it is. I can't remember this helicopter's name for the life of me. It's got a bomber engine in it right there, from the exhaust. Yeah, that's right, W. Yeah. So see the exhaust? There's a piston radial in here that would have been from probably like a B-17 or something. They were just using leftover bomber parts. Like it was a lot of off-the-shelf stuff. Like it's what I was saying a second ago. Not me. That EJ.
I don't know.
Isn't it true that the voice you hear is deeper than what it actually is? My voice sounds more nasally to me. It sounds like I'm talking through my nose all the time. And I sound like... To me, my voice sounds like this the entire time. Like I'm talking like this all the time. Like, I don't notice myself doing that, but I hate that. I hate the... Excuse my language. Mute it for a second if you're watching with your kids. I hate the hard-ass voice. Like, I hate that I talk like this sometimes. Like, shut the fuck up. Alright, it's good. You can come back. Put the cookie down now.
Take one backwards and
It's gross, dude.
engine went out here, but
I don't know if
I
you
mean,
guys hear it, but
This
yeah.
is an early dual rotor helicopter, so you'd have to have a drive shaft going to the front and a drive shaft going to the back.
Like, see, that was just me talking, but sometimes I go like, well, it's connected to the output spline, like output spline. Okay.
I don't think it has the engine in it. I don't think it has the engine in it either.
It's not a Chinook, no. This is I forget the name of it every time. It's an early Sikorsky. No, it's not. No, this isn't Sikorsky. I forget. So this thing is like I said, you know, you think about like a conventional helicopter, like it has, you know, people up the front, then it has the skids on the bottom, and then, you know, you got a tail rotor and a top rotor. Like, they really didn't, they tried a bunch of different things. They tried a bunch of freaking different designs. So this thing has the engine out back, right? And then the engine has two output shafts. One's coming out of the front, one's coming out of the back, and one of the drive shafts goes up and over the cockpit. So there's like a U-joint right here, and it looks like a drive shaft on a car, and it goes up and over. And then the other one goes back to a gearbox and up. Like, this is kind of honing in on the Chinook's design, but the Chinook's design is like way better than this. Hey, Swishio. If I showed you this, like, you got the engine kind of in the center of it, you know, you have this weird drive shaft mechanism. It's using a piston radial.
Where's the door? There's that. Is there a door on the other side? Is this like an old minivan where there's a door on one side? Oh yeah.
It's not a CH-46. No, CH-46 is... Yeah, see, like, look, this is still very much, like, right after World War II. It's just one door on the side. Because with airplane... The reason is because with airplane fuselages, doors weaken the fuselage. And, you know... The same is true for cars, to be honest. The cars have more doors. They're not as structurally sound. That's why, like, race cars have, like, 2 doors or no doors if it's, like, NASCAR or something. So, like, with helicopters, you know, you have those 2 huge blades, and the you know, up top, like, you have the 2 rotors, and those torque, right? They want to torque, so you need to make this strong. So that's why, I mean, that's why they put 1 door.
It's also egg-shaped.
It's a Pavilion. Yeah, that's the name of it. Pavilion Hg5. There you go.
Yeah, maybe. Yeah, so there must be a crew compartment up here, and the engine must be back here. Because I mean, look where the landing gear is. The main landing gear is in the center.
It's a tail dragging It's a tail dragger helicopter, but the main landing gear is midway up the helicopter. It's very weird. That's a very weird design. And then, like, you could see that design morphed into this design. I forget which one this is, too. And then these guys led to the Chinook and the Sea Knight and stuff. You were just excited and off the cuff piling him. Yeah. There you go. Like, the iteration is cool. They're like, oh, you know, move it back a little bit. You know, much more stable. You can extend the crew compartment, make it a little bit longer. Like, you can see the Chinook influences here. It kind of looks like it, like the dual rotors, for instance. But with the Chinook, with this one right here, the engine's further back, and they extended the fuselage. Think like a 727 has all the engines in the back, but it still flies, right? So they moved the engine further and further back, and then they figured out, like, oh, we could put a payload bay door back here if we put the engines up on top of the fuselage, and that's what the Sea Knight, the CH-46, and the CH-47, the Chinook, that's what they have. The engines are up top. They're up here. Oh, nice, App State. That's cool. What was said about the Russian plane? I don't know what I said. I forget what I said throughout all this. Did I see it? Did we go to a Russian plane? Ilya, the only Russian plane thus far has been the Hind. They had an East German Hind at Pima. This is a Hind D, so an Mi-24D. Pretty garden variety gunship. Didn't have any of the rocket, none of the weapons pylons had anything on it, but yeah. Let's see, where else? After, oh yeah. See, there's this thing, you know, they try to make this stuff, military equipment's usually really, really easy to work on. So everything is tagged and it tells you what it does. So if you know what to look for, you can tell basically what anything is. It's all labeled. Agricultural equipment. Yeah, sure. Look at that. I forgot we looked up in here. Yeah. Let me guess. I'm pointing out how mint the aluminum looks because desert. The thing that's painted white is the drive shaft that goes to the rear rotor, and I bet you on the other side of that gearbox there's a drive. Man, I'm talking fast. What am I saying? Hold on. Back it up.
We got no engines, Ted. Do we? do we? Oh, okay. There's the gearbox. See that? See that little cubby hole right there? There's an input shaft right there, and then that the thing that's painted white is the drive shaft that goes to the rear rotor. And I bet you on the other side of that gearbox, there's a drive shaft that goes to the other rotor.
Mm-hmm.
So the engine would have a drive shaft that went into this, right? And then this thing kind of looks like an upside down F, right? So you see this up here? That's the drive shaft that goes to the front rotor. So the engine goes in. There's a bevel gear that makes the drive go up. There's another bevel gear right here, makes it go out, right? And then there's another bevel gear on the other side of that, kind of like spider gears on a differential, and that goes up to the rear. The thing about it is that it's not a differential, it's a gearbox. Differential allows for different RPMs on your output shaft. So a diff on a car has one input on the yoke has an input, and that's connected to the pinion gear, right? And then that allows one output shaft. You have two output shafts, one that goes to each tire, and that allows them to spin at different RPMs, hence differential. Every time I call that thing a diff, it's not a diff, it's a gearbox. Because with helicopters, you do not want the RPM between the blades getting desynced. Because with a twin rotor helicopter, they'll hit each other. No good.
Banana was used in the early part of the Vietnam War. I mean, would this thing still have a bomber engine in it, guys? I mean...
No, that sucker's electrical, but I need a nuclear reaction to generate the 1.21 gigawatts of electricity I need.
What engine's in here? Is this a turbo shaft? I mean,
It's a bomber engine.
The exhaust disposition makes it
This would have had a piston radial in it.
Makes it look like it might be a not a turbo shaft, a radial engine. Cameron did not like being in the metal box.
Oh, sorry.
Yeah, it's aluminum, but yeah.
Well, it's
Still-
not the camera.
Well, see, like, that's the thing. Why did I feel the need to say that it was aluminum? Like, where did that come from? Somebody just said it's inside of the metal box. What, is aluminum not metal? Like, it's just weird shit that, like, verbal diarrhea that comes out of my mouth every once in a while. It's like, okay.
Signal that
Yeah.
it's affected. So.
Interesting. And you can see this is all aluminum and it's painted green. This is an anti-corrosion primer. They still put this stuff on planes.
Yeah,
To make sure that because aluminum doesn't rust, it corrodes.
that's right.
There's a difference. Rust is oxidizing. Difference there. I mean, no rust. I mean, no. LMJ, there's no rust on these.
I have a
things.
great
We're in the
jawline and
desert.
facial
The desert is
structure,
extremely
though.
warm and extremely dry.
Thank you.
We're not going to get over like 300 degrees Fahrenheit here, so it's not going to melt the aluminum. So
Are you agreeing with yourself?
warm, dry place.
More fact-checking myself, Neo, to make sure that I don't do more of the verbal diarrhea stuff.
You know, this stuff stays nice and strong. This helicopter that we're sticking our heads in is like 50 years old, I think.
I don't know if there was an HH-43. Let's see. We went through a lot of helicopters, man. Pima has a lot of stuff. That's the Space Pavilion with the weird shuttle up there.
Yeah. Signal's definitely better out here.
I mean, dude, they had everything, man. So much. See, that one I know a lot about. I bet you I talked about this thing for a long time.
Discovery, go at throttle up.
It's a great line of copters. Yeah.
The reason why I keep staring at my phone is because I'm trying to keep up with chat and talk about this stuff at the same time. Believe it or not, dude, like, part of the reason why I'm like, I'm trying to go crazy with this stuff is because, dude, like, keeping up with chat and trying to remember all this stuff at the same time, that's tough. That's a tough thing to do here. Never mind being out and with EJ surrounded by a bunch of frigging planes, dude, and helicopters. That dude, it's tough. Why do they all have their windows painted? So the sun doesn't melt, the sun doesn't oxidize the canopies.
Back, Huey, the UH-1 Iroquois, or the Huey helicopter. These things was like, this is what I keep talking about. This is when they're kind of like, okay, this is how you should make helicopters. And
Yeah.
That's basically what they did.
That's really, yeah, that's when they honed in on the design. Yep.
A lot in the Vietnam War. It's iconic for blasting like CCR and Charlie Don't Surf, and that kind of stuff. There were tons of different variants of this thing, some that are actually even still used by the day.
Let me guess. I'm about to mention the UH-1Y Venom. Let's see. Let's see if Past DJ knows his stuff.
The Marines still operate the UH-1Y, the Venom, which is a really, 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 really upgraded Huey. Yeah, and it saw civilian services the 212. That's right.
Yeah, the UH-1Y is a twin turbo shaft version of it with, dude, yeah, the thing's kitted out, but it's still the same Huey chassis. From all the moments you had done streaming, what was your favorite? Interviewing Charlie Duke, Clutch. I've interviewed people that have gone to the moon on stream. That's my favorite. That's been my highlight thus far. That was really good, and then Falcon Heavy test flight. Like, yeah, that was the good stuff. I like those museums. I wonder if those things could be preserved for decades outside like that. That's a thing for any museum, too. Oh, in Arizona, Pink, yeah, they'll last centuries. Yeah, seriously, centuries. Oh, yeah. You could leave that museum and have no one touch it for 50 years. The paint would be a little faded, and that's about it. Yeah, and then the next one over is a Kiowa. Yeah, see the Kiowa, it's funny. You see this thing? That little unicorn thing coming out of the front? That's a knife, mate. It's for cutting wires because the Kiowa is designed to stay low to the ground. So like if the helicopter's flying and there's like a power line, anywhere right here, the power line will go up and hit that thing and it'll cut the power line so the helicopter doesn't get stuck. That's a knife, mate. It's seriously, it's a knife edge on the front of the helicopter, which is really cool. Yep. It's a knife. Yeah, see, I talked about it. Yeah. It's designed to just guide the wire right in there, and then it clamps it and chops it. Yeah, most helicopters have those things. Anything that flies low to the ground. This one, yeah. This one has a, see, this one is out of order chronologically. This one should be down there where it says stop approach because this thing's still using a bomber engine. They used this in the late 50s, the US. Kiowa, it looks like Airwolf. Yeah, it's a, what is that? A Bell 206, I think is what it's called. This thing has a huge bomber engine mounted in the front, and the drive shaft goes up through the cockpit, which is very weird. So, like, see how the rotor shaft is, like, right next to where the people sit? It's because the engine is actually mounted at, like, 45 degrees, and there's a drive shaft that comes up through the floor of the cockpit, and then there's a U-joint right there, and it goes up to the rotor blades, which is, yeah, that's a very strange design. Once again, they hadn't really figured out, like, you know, put the engine on top of the fuselage and have the stuff have a lot of usable area underneath it. This thing, the Kiowa, I think is a OH-58 or something. This thing is kind of a more garden variety helicopter. Most helicopters still like look like this. So like you have the engine on the top, right? And then you have the cargo and crew underneath with the pilots out front. Like they hadn't really honed in on like the design, you know? It's like how, you know, when cars were first a thing, you know, you hadn't really standardized the controls yet. So like some cars had like ignition timing on it. Like the Model T had an ignition timing lever, so you could adjust the timing. And then that kind of went the way of the Dodo with vacuum advance, you know. That was sometime later, but you know, you get into any car nowadays, they all have this steering wheel, you know, like I was about to say they all have the steering wheel on one side, but that's not exactly true. So the steering wheel on your side of preference, okay? And then generally the pedals, wipers, everything is all in the same spot, you know? The shifter is always between the driver and the passenger, you know, for like a manual transmission. It's all, like the key is in, I noticed that on cars that are right-hand drive, the key barrel is still on the right side. It's still on the right-hand side. Not the correct side. It's always on the right-hand side, no matter where the steering is. So, yeah, it's all, this is kind of like when they figured it all out. That's what I keep talking about. I just never really explained what them figuring it out is. Because most people are right-handed? I don't know, man. Yeah, maybe. Do you have some good engineering videos on how a helicopter works that you could share? I'd like to understand helicopters a little bit better. We can do a little dive to start space news into helicopters, Nora, if you really want. I mean, the thing is, it's probably not gonna sit right, even if I explain it. Helicopters are weird, man. They're very weird. Helicopters have this thing called a swash plate, and the swash plate is the key to a helicopter. It isn't just a propeller blade facing straight up. The reason why that's the case, the reason why it's not just a helicopter that kind of faces straight up is because if you have a helicopter blade that's just pointed straight up, the fuselage is going to spin around. There's nothing to hold that fuselage in place, so it's going to pick up the centrifugal motion of the blades. So you have to combat that. But also, if you just have a helicopter blade that's pointed straight up, the engine's just going to go like this. It's just going to be able to go up. How do you get that whole thing to lean forward and backwards? That's what the swash plate is designed to do. There's a lot of... It's strange. I'm telling you. It's very weird. Hey, Tyler. Thanks for the host, man. Here, let me see if we can just get a good picture of one. Alright, so see these two things right here? Those are part of the swash plate. So what does the swash plate do? Well, like I said, if these blades were just at a fixed pitch, Nora, right? The thing would just go up, and then you'd throttle it, and it'd come back down. Helicopters actually don't do that. Helicopters have this swash plate thing on it. So, I'll introduce you to kind of how the controls work on a helicopter. All right, so you have two controls, well, three control inputs in a helicopter, okay? You have the joystick, which is in the center. That's called a cyclic, okay? Then you have your collective, which is in your right hand when you're flying a helicopter, or left. I mean, it really depends on the helicopter. You could, it depends. It depends on what you're flying. So then you have your collective. The collective is like a lever that you can pull back and forth. It's like a huge lever that you can pull up or down. It kind of resembles like an e-brake, kind of that movement. So like if you pull the e-brake on a car with a manual transmission, it's kind of like that, but it doesn't hold in position. It would be like an e-brake with none of that, you know, like you could just pull it up and if you let it go, it goes back down, right? And then, I'm getting to that, Neo. Getting to that. On the collective, you have like a handlebar, kind of like a motorcycle throttle. Same idea. I'll say what that's for a second. That actually, I can say that now. Or no, I haven't explained what anything does yet. So you have like a motorcycle rev on the end of the collective, right? This is garden variety stuff. Every helicopter is different. And then you have your pedals. You have rudder pedals, but they're not rudder pedals. I'll explain what they do in a moment. So. Cyclic. What does the cyclic do? The cyclic, well, it cycles the pitch on the helicopter blades. Every helicopter that flies, the blades have variable pitch. So what does that mean? That means the blades can do this, right? Every helicopter has that. All the blades on the big blades that are at the top. And then the tail rotor too. The tail rotor can do that. The variable, the cyclic controls the cycling pitch rate as the blades go around, and that's what this thing called the swash plate controls. Okay, so there's a couple of videos floating around on YouTube that I can show you. Actually, I'll show you one from the Kiowa here. Check this out. So, these blades can pitch variably. And the cyclic allows them to pitch independently of each other. Now, the blades are connected on a link here, which is on a strut that connects down to the swash plate right here. This thing. That's the key. Helicopters don't work without that. I mean, drones can fly without swash plates, but I'll tell you why in a second. Drones can fly without swash plates, but every like kind of regular garden variety helicopter has one of these. You have to. It doesn't fly. It won't fly correctly without that. So, if you notice, there's two Heim joints on the end of the swash plate. Those are connected to hydraulics, okay? The hydraulics are here and here. And then the swash plate is actually toroidal. There's a hole in the center of the plate, and it's a Heim joint. So you have your drive shaft power, which is going up through the swash plate, and then there's a sleeve around the drive shaft here, and that's what the swash plate kind of hugs. It's a Heim joint. If you don't know what that is, I'll show you. It's kind of like a Heim joint, but so see that? It can move inside like a ball joint, like what you'd see on the end of a strut. That's called a Heim joint. So it has that. So the swash plate is this part, and then the part of the swash plate hugs this thing right here, and the drive shaft goes through there. Okay. So there's a Heim joint in the center of the swash plate. That means that the swash plate can tilt independently, just like that ball joint. It can tilt independently of the drive shaft. But also, it's sleeved here. The ball part of the Heim joint can actually move up and down on this axle housing that has the drive shaft inside of it. And then you have two hydraulics connected. So, what happens when you adjust the cyclic? Well, that's not the cyclic, that's the collective. Give me 1 second. I guess we could start with collective. So what happens when you pull up on that lever on the side, the one that's kind of like an e-brake with the handlebar grip on it? When you pull on that, this is what it does. Watch the swash plate. The hydraulics push the swash plate up, right? They push the swash plate up, and then the blades, the pitch on the blades they increase the pitch on the blades. So what happens when you do this? What happens if you pull up on the collective? You're collectively pitching all the blades up. So the helicopter goes up. But the thing is that with a helicopter, eating while speaking. No, not eating while speaking. Ate lunch off stream so you wouldn't complain, and you're still complaining. So how about you take some time for a little bit? So now you have cyclic. This thing went full collective up, Nora. And now you have your cyclic control, right? So what does the cyclic do? Well, the cyclic cycles the pitch as the blade moves around. So see how it tilted up on one side and not the other? Right? It tilted up on one side. So when the swash plate rides around, one side of this goes up and the other one goes down. So if you watch the blade views here, watch. They change. Whatever blade is at the 270, 225 mark is going to be pitched. So this is what the center joystick does. The cyclic. It cycles your pitch between the blades. And if one blade is swinging around to the port side of the helicopter, port side would be over here for you guys, right? If it swings around over there and it pitches a lot when it's over there, that's going to create a lot more lift. The cyclic, because through cyclic pitch of your blades, through cycling the pitch, is able to move the center of lift around the center of mass, left or right. It actually, you could do forward and back as well. It temporarily does it. So if the blade, when it's in the 270 position, is pitched, right? And when it's in the 90 position, it's not pitched. This side of the helicopter over here is going to make insane amounts of lift, and that side's not going to make a lot of lift. So if the 270 side of the helicopter is making more lift, helicopter's going to bank to the right because you're making way more lift. Your center of lift moves away from your center of gravity when you use the cyclic. So it's applying more force on one side of the helicopter than the other because the blade is pitched, and then your helicopter rolls. Now, and then simultaneously, if you operate the other axis, it'll move and the helicopter will roll in the other direction. So cyclic controls pitch, and it also controls roll. If you pitch the thing forward, it'll cycle this in such a way so when the blade is at the zeroed position, it's making a lot of pitch, and when it's at the 180 position at the front of the helicopter, it's making no pitch. So that moves your center of lift behind your center of mass, right? It moves the center of lift behind the center of mass, and then the helicopter tilts forward. And then simultaneously for tilting backwards. So now, because of the swash plate and the collective and the cyclic, right, you can pitch the blades up collectively, or you can cycle the pitch between the blades, and that can get you to go in every direction. Yeah, now, that leaves the rudder pedals. What do the rudder pedals do? Well, the rudder pedals are a collective pitch for the tail rotor. You hit rudder right. What that thing is going to do is you hit rudder right, it's going to change the pitch on both the blades at the same time, and the tail rotor will make more lift. And if it makes more lift, it's going to pull the helicopter. The helicopter will yaw to the right. If you key in the left one, the blade pitch will go to zero. And if the blade pitch go to zero, those things won't make any lift, and the helicopter will want to go to the left. Because remember what I said. Helicopters without that tail rotor, the fuselage just spins around. It just spins around because there's nothing holding it in place. So the tail rotor is a propeller that's constantly pushing the fuselage and keeping it stable to make sure that the helicopter flies correctly, right? The tail rotor main shaft design is something that was invented by a guy named Igor Sikorsky. Yes, Sikorsky helicopters. Yeah, it was a Russian guy that figured it out, but he was a Russian-American. He immigrated to the U.S. How does a dual rotor yaw? Good question. I'll tell you in a second. Sorry, guys. My tooth is bothering me. So, is it off by 90 degrees from where the pitch of the blade changes to where the force is exerted? What do you mean, Nick? Yeah, helicopters' control mechanisms are 90 degree offset. Yeah, basically, yeah. So, yeah, if you don't have the tail rotor is basically pulling, it wants to go this way, basically in its default position. See how those blades are pitched a little bit? In the default position, it's pulling enough air just to keep the fuselage straight. And when you key in one way or the other, if you key in one way, it pitches the blades even more, and it makes the helicopter yaw right. And then if you yaw left, the blades go to zero pitch, and the thing doesn't move any air, and the thing that uses the natural gyroscopic precession of the blade to make the... Well, it's not precession. Well, it kind of is, but it makes... The fuselage will automatically want to go to the left. So you're not pitching the blades equally in either direction. You either pitch the blades to zero, and then they're in the 45 position by default, and then they move to 90. Or something like that. Those are just made up numbers. Yeah, the whole thing's a big gyroscope. Helicopters are naturally stable because, well, not really naturally stable. It's not naturally stable. Certain helicopters are very stable. Helicopters, if you fly them, especially a single rotor design like this, it's susceptible to what's called retreating blade stall. So if you think about it, when the helicopter's going forward, this is why helicopters can't go like 400 miles an hour, okay? The faster you go with the helicopter, right, the more collective you're going to need to do, the more pitch you're going to have to get in on your blades, right? Because you want to keep going. You have to keep moving the air. But But also at the same time, you need to pitch the helicopter forward so those blades on the top of your helicopter are grabbing that air. You obviously don't want to fly like this. The helicopter will just crash. You have to stay like 45 degrees, so you have to change the pitch on the blades. But also at the same time, you have to have the cyclic in the forward position. Now, when you do that, there's always going to be, picture these blades are 90 degrees off. So this way to this way, right? Instead of north-south, they're east and west. Now, when they're east and west, you have an increasing blade, so a blade that's going into the wind, and then there's a blade that's retreating away. It's going with the wind, right? This one is working like a wing, right? It's working like a wing because it's going into the wind. This helicopter blade is not working like a wing because wings don't work very well when you fly them backwards. So helicopters have this thing called retreating blade stall. The faster you go, the more pitch this blade is going to make when it comes around to the front. And the helicopter will naturally just want to do this. It'll just want to flip over and crash when you go fast. That's why helicopters really are speed limited, because there's only so much, and this is kind of an engine limitation. There's only so much torque you can put on this blade before they'll either shear right the hell off, this whole mechanism will just grenade itself, or your engine blade stall will stall the engine. You'll have a compressor stall on the turbine. So so what do you mean? What do you mean the blades will stall the motor? Well, if the engine can't apply enough force to keep these things going, right? They'll create. So like, say you collective pitch up. Say you're trying to pull up a load, right? Like you're trying to pick something up, and it's too heavy for what the helicopter can pick up, right? You'll pitch these blades to full, right, to try and get the maximum lift. But the engine doesn't have enough torque to keep the blades spinning at the right RPM to move that much air. They make more drag than they do lift if you slow down, right? So you get blade stall. Basically, your engine isn't strong enough to be able to move the blades at such a high pitch like that, and you get blade stall, and then it stalls the engine. It's like it would be like trying to start a car with a manual transmission. Try to do a rolling start in like third gear. It's not going to work. There are some cars where it could work, but generally it'll stall. Same idea. Because gravity pushing on the wheels, pushing on the ground, right, has more force than the engine in a higher gear, which is not designed for torque. It's designed for speed, right, or fuel economy, right? It's the amount of torque that the engine is making is not enough to get the car moving. It's not enough to turn those wheels. Gravity and the rolling resistance is overpowering that, so the thing stalls. Helicopters can do that too. It's called blade stall. That's different than retreating blade stall, right? So, rolling start. Yep. Yeah, so that brings me to, sorry, I needed to refresh myself. That brings me to the throttle, right? The throttle control. The handle that's on the end of the collective, Nora, once again, it's like a bike, it's like a throttle on a bike, on a motorcycle. Same exact thing. It's the same kind of thing. It's like a handlebar grip, right? But it's backwards, right? Because the collective is going this way. That literally does the same thing as a motorcycle throttle. However, there's a big difference here, okay? Helicopter engines basically have on and off. There's on and then there's off, and that's it. The engine needs to be going basically full blast the entire time, because you don't want to throttle the engine, right? Throttle the engine to 50% and then try to do a maneuver that would make the helicopter that the helicopter would normally be able to perform at when the engine throttles at 100%, right? You wouldn't want to do that, because if you're making 50% of the torque that you usually do, you try to maneuver the helicopter, blade stalls, engine stalls, now you're a floating rock, not for long, right? The handle grip is what's called a blade RPM. It controls the blade RPM. So helicopter engines, like I said, it's either on or off, but it's a little more complicated than that. So the default position, right, for blade RPM is like 90. I'm making these numbers up. This is just for analogy's sake. When you turn the helicopter on, the engine basically puts the throttle up to like 95%. The grip on the collective Nora, right, that can vary the throttle. It's a fine tune for the throttle. So you can either give it more throttle if you're trying to lift something, for instance, right? Or you could give it less. And it's like maybe a 5% deviation on your blade RPM. So like you could give it, it's like default at 95% throttle in the on position. You could put it to 100 or you could put it to 90. And that really depends on what you're doing. That's like if you need more blade torque or if you're trying to do something, you turn that collective to try and do a pretty close maneuver. Like say you want to make a tight turn in a helicopter. If I was going to make a tight turn in a helicopter, well, what do you need to do? Well, you want to turn. So that's cyclic right, left for you guys. You go cyclic right, pull up on the collective, and then increase the blade RPM, and the thing will turn on a dime. However, if you do that too quickly, you'll over torque the blades and the blades snap off. So you can't like just pull on that collective. You have to be smooth with it or else it doesn't, or else it'll break. This whole rotating assembly will just grenade itself if you're not careful, right? So what you do, you wouldn't just collective, cyclic right, collective up, full blade RPM. No, you'd ease into the corner, and then it would be able to turn faster. But you don't pull up on the collective like as hard as you can. It's not a gear shift. It'll break the helicopter or you'll stall the engine. And if you stall the engine, well, let's hope you didn't grenade this thing or else this thing turns into, a plane with no wings basically. Yeah, it doesn't end well. So yeah, with the helicopter, you have... Hang on a second. With the helicopter, you have your pedals, right? These guys control the tail rotor. Cyclic cycles the pitch on the main rotor. And collectively pitches everything on the main rotor. And then you have blade RPM. So, yeah, no, you need all your hands. Not all your hands. You need all your extremities to fly it. Yeah. It's very... Helicopters are tough. There's a lot of stuff going on. It's a lot of stuff to manage, which is why helicopters usually have one or two people in them, or more than one person in it. They usually have two people. All four hands, man. Yeah, your feet hands too. You guys have that, right? So, that's like a regular helicopter. There's other things like Chinooks. Check this out. Hg5. There's other things like the Chinook, right? Now, how the heck does that thing work? Somebody already asked some questions about it. Well, this is a dual rotor helicopter. So, Chinooks, here, Hg5 diagram. Chinooks are amazing, first of all. This thing is insane what it does. It's pretty nuts. So, you have two jet engines, okay? Twin turbo shafts. Why two engines? Well, one, you get more torque with two engines. If you have two engines, you can make more torque. Straight up, right? Remember that. So if you're trying to, lift something, right? Second part of that is redundancy. A Chinook can fly on one. If an RPG hits this thing and blows it up, the other engine will be fine. It can run just fine on one. I mean, you'll be down on performance, so you got to be careful. You'd have to adjust your blade RPM and make sure you don't do any crazy maneuvers, or else the thing will rip itself in half. But you have two gas turbines. These gas turbines go into a 90-degree gearbox, and then check this thing out. That thing right there is a gearbox that has two input shafts and two output shafts. So, remember, it's not a transmission. You can't switch gears with it or anything. It's taking power from two engines and putting it out to two rotors. But there's a thing with the Chinook. The blades both of these blades always have to be at the same RPM. If they're not, they hit each other. They always have to rotate in between each other like gears. So there's a synchronizer in here as well that synchronizes the output RPM from this thing, for the front drive shaft, which is right there, and the rear drive shaft. There's synchros in there. Kind of like a transmission, but kind of not. It's a little bit different. You're not shifting gears in a helicopter. You just need constant power in and constant power out. But you can have differential RPM in. One of the engines can literally be off and the thing will still fly. It doesn't matter if you're getting power from here or here. You can have differential power in, but the same power out every time. That is still ridiculous, even by modern standards. That's nuts. That's a hell of a piece of mechanical engineering right there. And that, dude, if that box goes, the Chinook breaks. That's it. There's no Chinook. Without that box, the blades hit each other, or you get differential RPM and then the blades hit each other. And then if you have differential precessional forces coming from each blade, the Chinook will literally rip itself in half. Here, I'll show you. Watch. This is for a little bit of a different reason, but yeah, if the blades go out of sync, watch what happens. When I say the Chinook will rip itself in half, I'm not kidding. This is what happens if the blades go out of sync. Those blades have a lot of torque, man. They have a lot of moment. This is why we still use the Chinook. It's such a good design. No one can make anything better. I'm dead serious about that. And that's not from me. That's from a Chinook pilot. Well, the back fell off. Yeah. Yeah, see that? That's no joke, man. There's a lot of different forces going on with a helicopter, Nor. That's why people just default to them being black magic, because one thing gets out of sync, that happens. And yet we see helicopters fly around every day with no problems. It's pretty nuts. So, from the synchronizer gearbox, right, you have an output that goes to a 90-degree gearbox up to the blades, and then these all have that swash plate thing going on that I'm telling you about. They have the swash plate, and these have the swash plate too. And then there's one that goes to a very similar gearbox, a 90-degree out to the back. Same, and then this one has a swash plate too, and that blade is on a longer drive shaft right there, because they can't have the blades at the same height. One is over the other, and even when they're over each other, they're still synced to never get near each other. Now think about this. This is one of the reasons why we still use the Chinook, like I just said. It's because it's ridiculous. Think about this for a second. So, remember what I said about retreating blade stall? And what I said about, over-torquing the blades? This thing stays in sync even if so like on a Chinook, you don't need cyclic control here on the front and rear blades. Differential collective pitch between the front and back blade is going to make the helicopter go forward and back. Somebody asked, well, how does the Chinook yaw? Well, the Chinook yaws by differential cyclic control. If the cyclic goes, when you yaw with the Chinook, cyclic right on the rear blade, cyclic left on the front blade will make it turn, like this. And then to make the Chinook roll, right and left, you have synchronized cyclic. So the cyclics can do this, they can do this, or they can do that. And then the collectives can either go up together, they can go down together, or they can move independently of each other to get the Chinook to go front and back. And now think about that. So say you want to pitch forward in a Chinook. You have differential collective. So the collective would stay the same, and the collective would go up on the rear rotor. The rear rotor now is making a lot more drag when the thing is spinning than the front rotor, but it still stays in sync. You have one rotor that's being torqued out of its mind over here, and this one is not being torqued at all. The RPM still stays the same. That's ridiculous. That is an insanely complicated piece of engineering. That's ridiculous. That you can torque up one blade give it full load on the rear blade and no load on the front, and it stays synchronized. This is why we still use Chinooks, because the guy that designed this thing was on another. This is another level of mechanical engineering. Helicopters are nuts, and this is what I mean when I say, like in the Pima videos, of them figuring it out. It's important to figure that stuff out, or else the thing doesn't work. But yeah, you can over torque those things too. Oof. Looks like engine failure. Cav that. Yeah, it looks like they had an engine failure. Yep. The mixers for the controls is insane on a Chinook. I've seen diagrams of it, dude. Yeah. From these line drawings. I mean... Now, think about all the control input that I just told you about differential cyclics and differential collective and synchronized cyclics and synchronized collectives. Guys, the Chinook's all mechanical. They did this before a computer could control this. The Chinook is from the early 60s. That's mechanical. It's a mechanical input. Hydraulic assisted mechanical input, but still. Some guy figured out a way to do that mechanically. I mean, later versions of the Chinook had a flight computer and whatnot, right? But the early versions of this thing, it's all mechanical. No computer. Which is nuts. That's unbelievable. That's a hell of a piece of engineering. Like I said, there's a reason why we still use them. Yeah, Ending Aura, that's right. Here. Because Chinooks can have variable collective pitch for pitching forward and back, the Chinooks can sit their hind wheels, what is it, a dog? Chinooks can sit their hind wheels and they can land on sloped surfaces. It's kind of crazy because if you stop and look at the blades, you can see that the front blade is pitched way more than the rear blade. Right now, those pilots in that Chinook they're just controlling the front blade right here. They're trying to be as gentle with that stick as possible with the cyclic. Right, because the cyclic in the forward and back axis on a Chinook does variable collective. That's how it works. You're not cycling anything. Have you seen this one? Yeah, I've seen those things. Interesting. We still fully use them. Yeah, a lot of people do. Sorry, not correct. Okay. So, right, you know how I am. I'm not an expert on this. I know a good deal. But if I get something wrong, sorry, not correct doesn't really help me in any way, shape, or form. Give me an explanation so I can understand, please. Because just saying sorry, not correct is, yeah. Like, Bright, I know you, but please don't do that. Please. Like, it's difficult enough to explain differential cyclics to people here on stream. All right? Especially on the internet where there's a lot of experts out there. So, if you could give me an explanation, that would really help. Because this is a lot of work to try and keep up with chat and explain this stuff at the same time. They carry the Hummers around. Yes. Mm-hmm. Yeah, they can carry more than that.
Discovery, go at throttle up.
So, like, I'm all for getting the information right. But if you're going to well-actual me, actually explain why you're well-actualing me, okay? And I swear, Bright, if this is on a technicality, I'm kicking you right in the balls. Because there's definitely differential collective going on right there. You could see it right in the blades. What about Ospreys? Do they work similarly? Yep. I'm gonna kick you right in the balls. Just right square in the nuts, so this response better be good. Well, actually, yeah. No, Bright. I know Bright. Bright's been watching the stream for a very long time. He's all right. He's good. I'm just busting his balls. Well, maybe not. Well, I might. It depends on what he says. It takes four control movements and combines it into 2 push-up bowls. Yeah, it's pretty nuts, man. Well, we're waiting. Nah, he's typing it up, Crocker, that's all. So, you guys want to talk about a V-22. Alright, what does he got? The pilots cannot control the blades indecently. They're just hovering level. I promise they cannot control forward and aft blades separately. No, I never said that they could. They're making fine movements, right? You're not controlling one blade individually. That's not what. If I said that, that's not what I meant. They're making very, very, very small adjustments, because right, they're probably. Now that I'm thinking about it, the blade's probably held back, right? So that Huey is tanking, not the Huey, the Chinook is tanking into the ground. Like, if they were just up in the air and they held it like that, the thing would probably do this, right? It's just basically pushed into the mountain, right? But they're making small adjustments to make sure that the pitch of the helicopter kind of stays the same. The pitch sticks kind of back, right? Those small adjustments are inadvertently changing the collective of each blade. Am I thinking about that correctly? Sorry, it's hard to do this, man. Those things are complicated. It's hard to explain this stuff. Yes, a bit back. Got it. Yeah. What I meant is those fine movements are slightly changing the blades. But yeah, you can't control the blades individually. That didn't come out right. Because I mean, you can't because the synchronizer. If you could control one individually, the synchronizer would break, like instantly break. Am I in the ballpark there? Does the Chinook have pedals, or would it be unnecessary? No, it has pedals. It has pedals. The pedals, though, Nora, control variable cyclic. So the front blade and the rear blade, when you hit the pedals on the Chinook, they do this. One cycles the lift to the left, the other one cycles it to the right, and the helicopter will turn. It's crazy. It's nuts. Blades or rotors? Yes, you are correct. All right, cool. Let's make sure we say it right next time. I mean, I'm telling you, Chinooks are insane. They're insane. They're ridiculous. But anyway, I mean, Bright, sorry if I didn't hear you right the first time. No, it's all good, man. I'd prefer to, like, okay, that's what I mean, dude. There's a difference between somebody, like, well, actually me, sorry, not correct, or just, if you explain it, man, I'm good. And Bright, you know this. You know that. You've been watching the stream long enough. I know, freaking... Sometimes I gotta remember who I'm talking to, you know? I know there's guys out there that know this better than I do. But those guys that know it better than I do don't have a stream. Most likely they actually work on the damn thing, and they don't really want to talk about it when they're off work. That's my job, you know? It's all good, brother. No, it's all good. Chinooks are still ridiculous, man. I would love to fly around in one sometime. But, yeah, okay. You guys wanted the V-22, huh? Okay. V-22s. They have propeller blades, right? And the propeller blades turn upright.
Discovery,
now,
throttle up.
When the propeller blades are up, when the rotors are upright, now what? What does it do? Hey, Whitney, what's going on? Nora, I want you to... Actually, Nora, I want not to put you on the spot. You tell me. When the Chinook has the... Or not the Chinook. When the V-22... has the, it's in helicopter mode. What is it doing? And they're getting upgraded engines and blades soon that so you've heard. Huh. Interesting. Yes, provocative. Like I said, right? Yeah, Foz, I've seen the video. It's pretty awesome. So, how does positive traction on Plymouth work? It just does, man. I flew both planes and helicopters. I'm constantly amazed how much you know about this stuff, and not just guessing, but actually knowing. Kudos to you. Thanks, Coop. I appreciate it. Sometimes I get it wrong, but it's mostly misspeaking because sometimes I read chat and while I'm talking, and that's sometimes that scrambles my brain, so I don't. Sometimes that scrambles my brain, so I don't say it right. It doesn't come out right. So Nora, okay, so you have a V22. Let's look at one, right? Let's look at the MV22, which is the Marines variant. All right, so take a look. I'm telling you, your mind's about to get melted. If the Chinook didn't amaze you, this thing will. And because dude, this is a Chinook. It's not a Chinook, but it's the same idea. I'll tell you in a second. So V22s, these bad mamma jammas, they're ridiculous, right? So when a V22 is like this, when the engines are pointed up, okay, it works like a helicopter. It's like a Chinook with the blades, instead of north-south, the blades are east-west, right? They're on the sides. So now you have helicopter controls. So you have a cyclic, and then you have a collective. If you pull the collective, both blades on each side, they pitch up. You push the collective down, they pitch down. So now you move the cyclic. What does the cyclic do? Well, you want a cyclic to the right. Okay? So you cyclic to the right. This one collective pitches down, that one collective pitches up. And then you roll to the right. Same thing with cyclic left. Now you roll to the left. How do these things yaw? With the Chinook, you have differential cyclics. But if you did that with this, right, it's just going to go this way. It'll just strafe left and right. So how does the Chinook do it? I mean, we know how the Chinook does it. How does the V22 yaw? How does it do that? Because it can do this. It can turn like this. Angle them forward and back. Shado, that works. It can do that. Yep. You can also change the variable RPM on these, if I'm remembering right. That one I'm not sure. I know that the rotors can do this. You can literally tilt one engine forward, tilt one engine back, and it yaws. Just a slight bit. You don't need to move it very far, like maybe 1 degree, and then the thing will just yaw like crazy. They can also use differential RPM. They can slightly slow down one engine, or one blade, than the other. And if you slightly slow it down, it'll... whoop. Gyro forces will push you in will yaw you in one direction or the other. No, Pop Bear, these things don't use bleed air. Those are C-130 engines, by the way, just in case anybody was wondering. These are the same engines that are on a C-130. So, I'll get to that in a second, Foley, if you want. There's a reason why the KA-52 is the way that it is, and I'll tell you that in a moment. So, you can... with the rotors, you tilt the right rotor forward, you tilt the left rotor back, the thing's going to yaw to the left. Simultaneously, you do vice versa, that thing's going to yaw to the right. Now, okay, so now you tilt the end, now you take off, right? You tilt the engines forward. Now what? Now your helicopter blades need to act like a propeller. How do you do that? Well, what makes the V22 crazy is that it has one control system. There's one control input mechanism. Like, you have a collective, right? And then you have a cyclic, and then you have rudder pedals, right? Now, when you're in helicopter mode, the rudder pedals make the engines do this, right? But when you tilt the engines forward, if the rudder pedals still controlled the same thing, the engines would be pointed forward, they'd be doing this, you'd roll. The rudder pedals would make the thing roll if they did the same thing. The crazy thing about the V22 is that the control systems change. They change, but they're using the same... You're using the same flight stick. It's not like you have two sets of controls here, okay? I mean, you do have two sets of controls, pilot, co-pilot, right? But they're the same controls. So now the blades are pointed forward. So now it needs to work like a propeller blade. The only thing that works on the blades, the cyclic control locks out. And the only thing that works on those blades is collective pitch. And the collective pitch is synchronized. So you can have a variable pitch blade like a regular propeller plane, right? The roll controls don't work because now that's on a control surface. Now you're using ailerons. So the controls, when you switch this thing to forward flight, there's a computer that changes the input. And now it operates like an airplane. That's part of the reason why the V22 was so complicated and why a lot of the early prototypes didn't work very well. Ended up getting a lot of people killed, which really sucks. But because they had problems swapping the control systems, and the thing would just... Because you need a computer to do this. There's no way you could do this with mechanical like the Chinook. There's not a chance. It's not going to happen. So, now here's the crazy part. Okay? The V-22 can't land like a regular airplane. It can't do that. It can't, like, land on a runway like a 737. Can't do that. Blades are too big. So, this thing is going to be landing in combat zones. You know, you forward deploy some Marine Force recon guys, right? And they jump out the back and their small arms fire. Say, guy unloads with a rifle and hits the engine and hits the oil pump, and this motor grenades itself. How do you get home? Here's the kicker. The V-22 has the same type of synchronization device in it as a Chinook. It can fly on one engine. One engine can power both of those blades. Nuts. Absolutely insane. Look. See? One blade is here, two blade there. Right? So when one of the blades are facing in like this, the other one's facing like that. It literally has a synchronizer. There's a drive shaft, an output shaft from this engine, from this C-130 motor that goes here, and there's a synchronizer in this part of the aircraft. And then it goes out here, and you can literally have one engine control both blades. So if one engine fails, whatever, you fly on the other one. And that other one, because the thing can't land like an airplane, controls both the rotors. Yeah, it has a synchronizer like a Chinook. So on top of all the stupid control input stuff that I told you about, on top of all of that, you have a synchronizer in it because it has to work like a twin rotor helicopter. You have to keep the blades in sync. If you don't keep the blades in sync, well, the thing will rip itself in half. And then on top of that, MV-22s can store themselves because the Marine Corps uses it, which means it needs to be able to land and stow itself on a boat. You know how it does that? The whole top wing box rotates 90 degrees, the blades fold in, and the engines fold down. So they fold the blades in, the engines move forward, and then the whole thing turns. The whole wing box can turn. Like that. So you can store it on a ship because real estate is limited on an amphibious assault ship. It has all that stuff that I just told you about with the synchronizer, and because it's a Navy plane, you can fold it up, and it does that automatically. By the way, yeah, you don't need guys like up there folding the blades. It'll just do it by itself. The blades just the motors move forward, whole thing moves sideways. Does it by itself. It's implemented. It's built into the design. Now there's all that stuff that I told you about. Think of what it's like being a V-22 mechanic. Think about all the maintenance that thing freaking needs to fly correctly. Like, all those systems, there's so much stuff, man. Oh, my goodness. So the engines can tilt independently, or they're in sync? They can... When it's in helicopter mode, they can slightly move independently of each other. Just very slightly. Otherwise, they're in sync the whole time. Yep. Yeah. There's a guy that watches the stream. I won't say his name. There's a guy that watches the stream that was a V-22 mechanic. And he's like, the reason why I know all this stuff is because he taught me. He taught me how it all works. Oh, yeah. Also, just in case this thing wasn't nuts enough. All right? Yeah, it has asymmetric components inside of the fuselage, just because frick you. Here. So the V-22 has an APU, just like any other plane. The APU is on one side. So the APU is built into one side of this nacelle, right here. It's actually behind and to the left of the center of mass. You have an asymmetric CPU, you have an asymmetric auxiliary power unit, and there's a fuel tank on the other side. Yeah. Yep. Okay. Yeah. Okay. Yeah. Sure. The F-22 is the same way. C-130 is too, Pythos. Yeah, a lot of people don't know that. Yeah. Which year What year are these from used? V-22s were designed to replace the MH-53 and thought up. It's an American design. Bell and Boeing Vertol, I think is what it's called. So it was a joint project between Bell and Boeing owns Bell, if I remember right, but doesn't matter. Late 80s, early 90s, computer controlled. In the late 80s, early 90s. That's why a lot of them had problems. They killed a lot of people, believe it or not. Yes. Yeah. Is fuel in the wing? You know what, Hip? I don't remember. I don't remember if this thing has wet wings. I'm inclined to say yes, but I don't know for sure. Somebody's going to have to fact check me on that one. All folded up. Yeah, someone's going to need to fact check me. I think it does, but I don't know for sure. Yeah, see? Ridiculous. 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 It's a ridiculous design. Like, alright. Yeah, and then there's a freaking AV-8B right next to it. You want to see something crazy? I'll teach you about that thing. Harriers are nuts. They're insane. They're insane. It is replacing the C2. Which hazard pay be danged. I am adamantly refuse to rise in one. Oh, I'll fly in one, Victory. Sure, why not? It looks like it has several tanks. I know the tanks are interspersed around, but yeah. And once again, yeah, thanks for the gift, fellas. Yeah. This thing does it automatically. What the frick? Harrier's the plain version? Nah, Harrier and the V-22 aren't related. They do the same thing, though. Like, technically, they use totally different design principles. Yeah, no, V-22s are nuts. They're insane. They're ridiculous. I mean, but, you know, that's what happens when you try to combine the ridiculousness of a helicopter with an airplane. It's half airplane, half helicopter, which is just, all right. Yeah, it's like 2 times speed. Yeah, of course. Including right aft off of center tanks. The thing is nuts. It's just, I mean, Bright, she's a beast, dude. I love them. But it is complicated, man. This is a complicated piece of equipment. It's crazy. It's crazy. Yeah, the V280 is the successor to it. Yeah. Here, check this out. The V280 is even more ridiculous. They have, instead of the whole engine moving, the engines are fixed. And the propeller blade is the only part that moves up. But it's the same idea. It's just as ridiculous. This is like the Mark II V-22. Yeah, Kaiser. No, once they work the kinks out, man. Now, I told you about all this stuff that this thing does, guys, right? All the different things that it can do. It can fold up. It can do all this other stuff. Think about how long this took to freaking engineer. Think about all the testing that you would need to do to get this thing right. Like, all the design analysis, the material analysis, computer simulations. This thing is more complicated than some rockets. Yeah, V-tail. It's weird. It's a ridiculous airplane. Ridiculous. Think about all the time that thing took to engineer. It's quite literally nuts. It's nuts. It's absolutely insane. And yeah, I agree with you, Kaiser. They're actually really good now that they work the kinks out. It works great. They work fantastic. Nothing can do what that thing can do, except for the V280 and the SB1. Yeah, exactly. Yeah, they put fly-by-wire system. The early computer-controlled systems weren't very good. Will it make coffee? I bet, yeah, maybe. Great piece of engineering. I agree, Whitney. Yeah, it's crazy. And see, you know, we've talked about V-22s, we've talked about Chinooks, we've talked about all different types of stuff. See, the Chinook, that's pretty complicated. Here, check this out. You want to see what the Russians cooked up? Look at this thing. Now, you guys tell me, how does the Ka-25 work? How does that thing work? The Defiant X, yeah, the SB1 Oradon. You have contra-rotating blades. So, Nora, look at this thing. double swash plate. You have 2 swash plates stacked on top of each other here, and one of the swash plates, the 2 swash plates are stacked on top of each other, and they can both do this, right? They can both move independently. One of them has longer links to the first blade, and the other one has longer links to the second blade. Yeah, they're 2 blades stacked on top of each other. This basically makes it so you have 2 blades rotating. They're called contra-rotators, right? One is rotating one way, one's rotating the other. They cancel gyroscopic forces out, so you don't need a tail rotor. You don't need it. This thing does the same as the Chinook. But instead of one blade being out in front, one blade being out in back, right? They just put them on top of each other. The reason why the Russians did this is so it could fit better on a Navy ship. The reason why they did it is so they could fit on the aircraft carriers. So they could fit more of them on the flight deck. Yep. I did have a helicopter like this, Hein. I've seen the Chinese version in action. Yep. The Ka-50 uses the same gearbox and everything floating. Yep. Yeah, it's a shame. It's a shame what happened to those ships. They made them into a hotel or something stupid. But yeah, see, this thing would have had a bunch of these things on there because honestly, the Soviets never really had like a big aircraft carrier like ours until the Kuznetsov came along. Their carriers were literally submarine tenders. Yeah, the Kiev and the Minsk, these things with the angled helicopter deck. These things were submarine tenders. Yeah, the entire Soviet Navy was built around the submarines, and everything that's on the surface is just a support ship for the submarines. They started to change that in the late 80s, though. They started to get like a regular, more run-of-the-garden variety, run-of-the-mill like kind of carrier. But yeah, for the most part, they had just helicopter carriers until they made the Kuznetsov, which is a kind of a fixed-wing carrier, not a submarine tender. What do you think of the Raider X? Yeah, guys, that's getting into the SB-1. So you want modern helicopter meta, right? I've showed you pretty much all the different things, right? From the Pima video to all the way up to the Ka-25 and the Ka-50, right? Now you have something like the SB-1. The SB-1 is, well, take a look. Yeah, of course, Victory. I mean, that's what happens when it's the Soviet Navy versus, like, Texas Navy. You know what I mean? Like, it's generally what happens when the country collapses. You know what I'm saying? So, you have the SB-1. Now, you guys tell me. Nora, knowing a question about the VTOL type helicopter. Do you have to pitch up when you change from plane mode to helicopter? You want to see a V-22 taking off? Hold on. Before I talk about the SB-1, I got you. Here, look. Watch this thing. Check that out. Oh, what's up, dog? I heard you wanted to take off. Watch this thing lift off the ground. Watch how fast it gets up off the ground. Yeah, he has them pitched forward so the thing can taxi. You're right. When the thing goes, it goes. Let's see what happens. Alright, watch this. Yep, see ya! Oh, it's so freaking cool. That thing is so legit. How that thing doesn't grenade itself, just try to take off, the thing just breaks. It's unbelievable. The fact that it stays in one piece is absurd. And now you're in plane mode. And he did pitch up. Yep. Basically, when you move these forward, it naturally wants to make the thing go up. Like I said, these things are designed to get in somewhere, get in, drop off or pick up cargo, and get out fast. You have all the benefits of a plane and all the benefits of a helicopter combined into one vehicle. And it's about twice as complicated because of that. But engineering is always a trade-off, especially when you're on the battlefield. I see them all the time over Mission Bay. They're so freaking cool, man. It's such a cool design. I'm sorry. The V280 is cool, but that thing is nuts. I mean, the V280 is a design that came out in the last 5 years. Same with the SB1. The V22 is 30 years old at this point. That's what makes that ridiculous. Like, the F-15 was still considered a new airplane. You know, like in the late 80s. Well, not really new. It'd been around for a little while. But still, the fact that that's a 30-year-old design is just ridiculous to me. Have you seen the Chinook do a U-turn in midair? I haven't seen it, K5, but I know it could do it. Yeah, the EXs, devils. Can you believe those EXs are hot, man? Those EXs are nice. Is that Farnborough in the UK? Yeah, I think so. This is from Airboyd's YouTube channel. I'll link this up here if you guys want to see it. Yeah, that's true, Gaw. Yeah, floating, I'm telling you, the design, they started... Don't quote me on this part. I don't know if this part is right. They looked at, like, special operations and stuff. So Marines are kind of special operations, but they're not. They're not special operations. It's the Marine Corps. And then there's Marine, like, Force Recon, and then there's Marine Corps Special Operations. There's a bunch of things, if I'm remembering right. If there's any devil dogs in here, correct me if I get it wrong, please. I will eat crayons with you later. All right. So this thing was made to be able to get somewhere fast, drop people in, and then get out real quick. So, like, it's kind of designed for special operations, but it's also not. There was definitely a need at the time because the Cold War was all proxy stuff, like Vietnam and the Soviet Union and Afghanistan and Korea and stuff. Like, so it's very tactical, so you need to move around real quick. You need to be able to get guys there. And if you didn't get them there fast enough, well, you lose, right? So this thing is really designed to get somewhere quick, land, drop people off, get out fast. And then a gunship will come in and, you know, do what it needs to do. Sorry for all the helicopter questions. No, Norris. I said it would be fine. I said it would be fine. MARSOC is Marine Special Operations. I assume SEALs use these too. And do it with no runway, Toto, exactly. You need to be able to go as fast as a plane, but you might need to land in a soccer stadium, for instance. I'm pretty sure they tried that one time. I've shown that on stream, what happens when you try to do that with a C-130. Doesn't end well. That doesn't work very well. The V-22 is true embodiment of the Marines, is the true embodiment of the Marine Expeditionary Force in readiness. Fast to battle and fast to extract. Bingo. Because the Marines are a specialized thing, it's not special forces. They're a specialized combat soldier, I guess. You need special equipment like the V-22, like a Harrier, like a Pavlo. Friendly Pavlo inbound. You need that special type of equipment because what Marines on paper are designed to do is Marines are designed to kind of be all-terrain with an emphasis on, like, going from sea to shore. So it's amphibious. They're amphibious. They're amphibious specialized troops. You can do whatever. Like, consider that compared to, like, the Army. The Army guys are designed to fight on land. And then the Army has mountain units too. The Marines are kind of designed to, you could do whatever, but it's an emphasis on amphibious assault. So, you know, God forbid there's, you know, some type of beach assault like another D-Day or something. I would never want that to happen. The Marines are the guys for the job. Yeah, that's what they do. That's That's what they're kind of all about. Beach assaults, which is why they're the gung ho ones, you know. Go everywhere, first in. Yeah, the Marines are the guy. Yeah, the Marines are the guy that go there and kick the frickin' door in. Yeah, they're like they're the first ones knocking on your door, and you do not want them knocking on your door. Yeah, they did get rid of the tanks, Floofy. Yeah, interestingly enough, they went back to more amphibious mobility. I was reading about that the other day. Yeah, they don't knock. Well, they knock, Falcon, but it's with a shotgun. Go, you know. Freaking gung-ho, man. Get some. Marines are for breaking things on ships and establishing beachheads and forward operating bases. Yeah. They're crazy, man. So they need a crazy piece of equipment like this because what they're trying to do is nuts. In a good way. Like, that's the cool kind of nuts. I mean, and this is not just the U.S. Marines. The Royal Marines are the same way. The Royal Marines are the same way. I mean, I don't know if Russia has something equivalent to the Marine Corps. Somebody would have to clue me in on that. I don't actually know. I probably should know that information, but I don't remember. I don't know what their Marines are called, if anything. U.S. Navy Hg5. What's that, Caviar? Whoa. Is that pulling cargo off of a carrier? Yep, that's exactly what it's doing. All right. It's moving cargo between ships. Damn, that's oh, man. VDV? I don't know. They do, but it's not as specialized. Yeah. Like, here, let me see. What is this? This paved the way for the V-22. Yep. They also break things like toilets, pipe speakers. Well, it's not their job. It's not their job to fix it. That's your job. Russian Naval Infantry, NPR, Russian Moskoye Moskoya Peklota Rossi, Russian Sea Infantry. Interesting. Yeah, okay. Yeah, I mean, that's what they're designed to do. The Royal Marines and the U.S. Marines, the Royal Marines are probably the closest to the U.S. Marines. They do the same thing. Those guys are nuts, man. So this guy's in a CH-46, which is the mini version of the Chinook. It's that's actually the Navy variant of the Chinook. The Chinook really isn't designed for sea operations. You can do it, don't get me wrong, but the Army uses the Chinook. The Navy and the Marine Corps use CH-46s, which is like a mini Chinook. Okay, yeah, that maneuver though. Did you guys see how he swung that tail in there? Look at that. Drifto! Nani? Helicopter drifto! The C-9, yeah. That's a cool helicopter, man. Underrated, because everybody thinks it's a Chinook. Just power slid that cargo right in there. Yep. Drop it on the deck. Yep. Send the green guys. Green guys, go and get it. That's cool, man. Caviar, this is dope, dude. Yo! Oh, that is so tough, dude. That's so hard to do. I don't know how that helicopter flies with that pilot's brass balls in the front seat. You know, guys, it doesn't look like much. A helicopter, picks it up and drops it. Watch the helicopter. Look at how windy it is. Look at how windy it is. This ship is underway. The ship's moving. This guy is keeping this helicopter steady in winds with a headwind coming from the side, picking up cargo. That's pretty nuts, man. It's crazy. Yeah, it's crazy. Ridiculous. There's a resupply ship over there. Yeah, I mean, that's what I mean. Those dual rotor designs, they're cool. So, last thing up here. Look up Chinook handbrake turn. That's what people keep wanting me to link here. Chinook handbrake turn. All right, let's see. All right, let's see what we got. Here, hold on. I just want to make sure the helicopter doesn't destroy itself. No. Okay, cool. All right, let's see. Fastest helicopter in the U.S. inventory right there. Holy crap. Dude, he's going... That's fast, man. Now, knowing what... Here, before I do this, knowing what I just told you about helicopters and all the moving parts in this thing to get it to work correctly. In Victory, yes, you're right. If it's leaking oil, that means it has oil in it. You're absolutely right. Same is true for old cars. Knowing all that stuff that I told you about, you know, synchronizers and blade loads and how easy it is to stall a helicopter, to get blade stall, and then blade stall will go back through the drivetrain and stall the engine. Watch this. Oh my god. Okay. Oh my goodness. Yep. What the frick? You got... Frick you, it can do that. Holy crap, K5, that's nuts. I understand why you wanted me to see that. That is... Dude, that thing shouldn't be able to do that. It should have ripped itself in half. Man. Can I... Dude, I want to see it again. Hold on. Let's put it with the sound on. Ready?
Discovery, go and throttle up.
Third Twitch baby from Caviar. Bro! Oh my god! I wonder how much torsion that put on the freaking fuselage. Holy crap!
So a rather high-angled turn you saw there. It's called a Morgan.
Dude, even the announcer's like, wow. He's like, a high turn you saw there. That's crazy, Coop. I've seen that in real life. It's nuts. It's nuts. The Great Canadian Bear Trap in action. What is this? What do we got here? Oh, I don't like this. Oh my, no. Holy balls, dude. Yo. What the frick? Dude, he bounced the gear. Oh, I hate it. I hate it so much. I hate it so much. How are you doing this without crashing this thing? Is that thing on a hook? What the hell just happened? Wait, are they reeling that thing in like Moby Dick style or something? Yeah, he sent it. Can you see that? The guy's just like, nah, I'm done with this. So they're reeling it in. They're reeling the freaking thing in. Reel it in. There she blows, SpongeBob. Sponge boy, me Bob. That's nuts. Category 3 with 20 foot sea. Oh my goodness. Yeah, Bill, right? Helicopter boy, me Bob. Welcome aboard. The guy's just like, I'm done with this. The frickin' hell with that. The hell with that, man. I ain't doing this no more. Here's the Wikipedia article on it. All right. I gotta read. Let's see. I want to still talk to you guys about the SB1 because the SB1 is insane. You think the Chinook was nuts? You think the V-22 was nuts? The SB1 is crazy. It's really, really freaking cool. So what does this do? Helicopter haul down and rapid securing device. The herds or bear trap enables helicopters to land and depart on smaller ships in a wide range of weather conditions. So, oh, it hits the, oh, it's on the tether point. Okay, I see what it does. So the helicopter hovers over it, right? The guys take the wire from the hoist and they put it in that thing and it pulls the helicopter in. Cool. Dude, that's nuts. You gotta be kidding me. It is a bear trap. It's a bear trap. Yeah, so when the pedo or whatever this thing is called, the ding alarm, when that gets down here, it clamps it. It's a freaking bear trap for a helicopter. Oh, dude, that's so legit. I wouldn't, Devils, I would not like doing this. I'll be honest with you. I would not, dude, you do not want a helicopter that's in the air tethered to something. Because if you pull too far back, right, and you tension the line, not torsion, if you tension the line, the helicopter does this. It'll flip over and crash like that, very quickly. Like, you have to have nerves of steel to do something like that. You don't land, it pulls you in. Yeah, but God, the ship is going up and down, man. Ship's going up and down on the waves. So if you have to like fly in formation with the ship. If you don't and you tension that cable, it'll either A, snap, or your helicopter does this. It'll flip. Sorry about posting links all the time, but here is the reverse. Let me see. Alright. No, don't worry about it, guys. This is awesome, dude. I love watching this stuff with you guys. I like explaining it because I know what it does.
I think sometimes this maneuver is used when you've lost power to the aircraft, so either an engine failure or...
Hey, Bright, are you still here? Is that the same thing that we were talking about where you're back on the cyclic? That's the same maneuver, right? Recovery assists securing in transit. Yeah. Oh my goodness, man. That's nutso. What the frick? Oh, don't mind me. I'm just taking my Chinook for a walk. That doesn't look right, man. That boy ain't right, I tell you what. That boy ain't right, I tell you what. Wait. Of course it can do that. Why wouldn't it? Why wouldn't it be able to do that? Yeah, of course. What the frick? Oh my god, that's so freaking cool, dude. That's so freaking cool. Are we sure that's not the same footage, just rewound? The guy sticks his head out. What up? Oh my goodness. How does that even happen? Alright. Okay, sure. The guy was like, yeah, you saw that. It was pretty cool, wasn't it? You know? See if you can find a max performance takeoff. It took this picture of a heli tethered. Oh, nice. It's a Cobra. Cool. I can post a link of how I would hook sling loads to Chinooks in Afghanistan. You have 60 seconds. Post away. Cyclic maneuver extracting troops. Kev, I think we've seen that. I showed it real quick, but here, we'll see it one more time. Like, once again, remember, the Chinook has all those damn moving parts. All the moving parts, the synchronizers, all the control systems. It's not computer assisted. Maybe the newer ones are, I don't know. This isn't me, but that was the base you were stationed at. I'll check that out in a moment. It has all the moving parts. Alright. Yeah, he's right. You hear what he said? Freaking sketchy, man. Yeah, yeah, freaking guy. Unbelievable. That's ridiculous, man. Freaking sketchy. Yeah, yep. Why is it tilted? Chinook can land on the side of a hill. That's what that maneuver is, Laserman. It uses differential collective pitch to, like, dude, I don't. Okay, all right, fellas, guys that served overseas, guys that served in the sandbox and stuff like that. I don't think people understand how valuable it is to be able to land a helicopter on the side of a hill. Helicopters, if it's not a Chinook, they need flat ground. That's why helicopter pads are flat. That's why I don't see a helicopter pad that's like this. If you're in an area that's very mountainous, Afghanistan, you're in an area that's very mountainous, being able to land on the side of a hill is a very, 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 very good capability. I bet you Chinook saved thousands of lives doing that. Yeah, Afghanistan ain't flat. An absolute must. Yeah, it's pretty mountainy. Yeah, so Laserman, like the Chinook uses differential collective to be able to basically put its hind wheels, the back wheels, basically it could just sit there, right? And you can have one blade just with no pitch and the other blade with a lot of pitch, and the thing just, it can just sit there and do this. So you can land on the side of a hill. That capability cannot be understated. How important that is. Like, Afghanistan's pretty from the air. Yeah. The DDG-51 flight deck is slightly tilted forward. Do I want to know why, Victory? Saw a Chinook being airlifted out because it clipped a mountain while landing. Everybody was okay. Yeah, and if you didn't think Chinooks were ridiculous enough, they also float, by the way. Yeah, they can float in water, so they can land in water. And I'm not talking like hover over water. They can land in water. They figured that out in Vietnam. I don't want to know how. But, alright. The next footage was from Kev. What do we got here? Let me see.
He is going backwards.
Honestly, I don't know why. Nice. The D models can shut down while in water. We never tried it, but they can. Yeah. The Chinook is not an amphibious thing. That's what the Sea Knight is for. But even then, that thing doesn't do that either. But yeah, it can. We use them in Alaska for carrying 105s. That's cool, LCD. I mean, dude, look. You know, you guys know how I feel about fighting. You know, it's not really that big of a fit. But, dude, the toys are cool, man. That thing is really neat. Guy never touched the ground. You know, okay. Another thing with helicopters, you know how difficult it is to just hover above the ground, like, precisely like that, so some guy can hook something onto the bottom of the helicopter? That's not easy. It's not easy. In real life, you have, windage, and then you have the ground effect, too. Now, I'll be honest, I'm not sure if the ground effect is affecting the Chinook too much, but I don't want to say that it isn't either, you know? Sadly, I was a wizard is to a cargo Chinook crash while carrying a brand new pickup truck. Did everybody survive? Clipped the power wire and it was messy. You never want to see the blades get shot out everywhere. Yeah, Dama, hey, no. I mean, the Chinook's cool, but it has its limits, just like everything else. That was fun as hell. You also have someone discharge all of the static electricity. Yeah, right. The last thing you need is your helicopter getting EMP'd because the guy forgot to frickin' put his shoes on. Right? That's not how that works, I know, but still. It lifts 26,000 pounds of weight. Class 6, 26-foot straight. Death, it's ridiculous. It's a ridiculous piece of equipment. The ground effect can be super bad. Think of a circular motion. Think of a circular motion of hair hits the ground and it goes up and gets sucked back up by the blades and pushes you down. Oh, yeah. Yeah, that's what I'm thinking. Like, the vacuum of air is, because it's swirling off the ground, it can just keep swirling. Oh, dude, that's dangerous, man. Yeah. Oh, jeez. It's like a helix almost, right? And then it's a helix, and then it hits the ground, and then it helixes back up. Oh, ooh, yeah. No, that's, yeah. Now I have more respect for this guy for doing that. Like, the fact that he could just sit there. Like, dude, look, he's... Okay, build the helicopter KSP, try to do that. Try to do that, right there. Try to hover just precisely over something like that and not crash. It's ridiculously hard. Nah, Bright, it's all good, man. Vortex ring state is an issue. Ring vortex, yeah. Because this thing is swirling the air. So when the blade goes by, the blade creates a vortex, right? But since these blades are pushing the air this way, the vortex is going down. It's going down like this, and then the air is kind of swirling like this, and then it bounces back up. Yeah, the air does bounce off the ground. You force the air at the ground, it'll swirl off the ground and come back up. So the helicopter just kind of sits there doing this. Because if you don't get laminar flow going into the blades, then they don't blade. While descending ring vortex ring swirl can kill. Yeah, I bet. Yeah. Truth is, you can't really predict when that happens analytically either. There's a big reason why the Chinook might not get retired for another 50 years. There's so much real-world experience on how to fly it. Plus something new into service, you have to watch servicemen crash it for 10 years all over again. Yeah, right? I mean, they broke the mold with that damn design. Chinook's genius. Here, Coop, let me just give you regular, okay? Here, I'll just add Coop. Now you can post links. Just ask me before you do. I'm just trying to keep up here. Oh, no, we needed that. All right. Thanks, Chief. Oh, it's all good, man. So max performance takeoff involves the aircraft turning while going up. This way, both forward and aft blades can get clean air. So yeah, if you're doing this, you gotta basically. Oh, man, that's crazy. Why do some helicopters have aero controls? Can they control it with all the blades? Depends on the helicopter, Swishio. So a Hind, for instance, here. So if we look at a Mi-24, the Mi-24. It has wings. It has little stubby wings on it, though, and the Russians use that to mount the weapons pylons. Now, the Hind, what it can do is, you go forward on the cyclic, the Hind can go down the runway, and it can take off like an airplane, kind of, with the wings, right? If you're carrying a super heavy load, you can get going, and the wings can get you up off the ground. Now, simultaneously, when the Hind is flying through the air, the Russians figured out that if you put wings on the helicopter on the side here, well, when you're going forward, just like how you can take off, the wings generate lift. If the wings are generating lift, the blades don't need to work as hard. So you can carry, presumably, a heavier load than what the helicopter could theoretically pick up. In this case, the Hind can carry a bunch of people and a bunch of guns. It's a transport helicopter and a gunship rolled into one. So this is to keep load off the blades to make sure the blades don't snap off. That's why helicopters have wings. I found a link of a Chinook being lifted by M26. Yeah, spaceflight. Yeah, Hinds are cool, man. It's a cool helicopter. I really like them. They're really neat. It's an old design at this point, but so is the Huey. I like the Huey. Hueys are cool. So, all right, check this out. I was trying to turns out that the Chinook is a lot cooler than, it could do a lot more things than I thought it could, which is nice. Enter this thing. This is kind of the next generation of helicopter right here. So that's the SB-1. Now, for the people that were here at the beginning of Space News that, wanted to learn about this, And, you know, I learned about, you know, told you about swash plates and how they work, and contra-rotating blades, how those work. They cancel each other out, so the thing can fly really stable, right? Look at that thing. What does that thing do? Huey in the news. You like Huey Lewis in the news? No, their early stuff was okay. But when sports came out in '83, I really think they came into their own, commercially and artistically. But why does the MH-60 have flaps on the back, for example? Stabilization. They're a stabilizer, Swishio. It's a stabilizer. Because when the helicopter's flying forward, it still kind of flies like an airplane. And here's the thing. That's what the SB-1 is nutso with. Now, I don't know exactly how this works, but I think I got an idea, okay? So, this thing can fly around like a helicopter, but that thing can go just as fast as a V-22 can. It can fly as fast as an airplane, right? Now, how does it do that? What do you mean? What do you mean it can fly as fast as an airplane? Well, I mean, this thing sticking out the back kind of is a dead giveaway for it being able to go fast, right? And it looks like it's very aerodynamic, right? This thing has twin contra-rotating blades. So when the thing takes off, it's in helicopter mode, right? And it takes off, it's in helicopter mode, and these two blades cancel each other out, so it works like a Ka-25. So you have double swash plates on top of each other, right? And if you want to roll or yaw this thing, right, you have differential RPM. So one slows down slightly over the other, and the thing can yaw. Now, this thing has twin turbo shafts, right? There's two jet engines on this thing. The jet engines are designed to turn a drive shaft instead of make thrust, but they do make a little bit, but they have twins right behind, and they move. There's a drive shaft that goes forward into a gearbox that's right here. And then that has two drive shafts coming out of the top, but one drive shaft is wrapped around another, because you need two drive shafts going right, one to the first blade, one to the second blade. So one is a pipe and the other one is a solid tube, and they're inside of each other, just like a Ka-25, same idea, or a Ka-50 or a Ka-52. Now, simultaneously, this thing has a drive shaft that goes down and backwards. The drive shaft that goes down and backwards goes to that propeller blade, and that propeller blade back there has variable pitch, just like an airplane propeller, like on a C-130 or an A-400 or a Q-400. Pick your propeller plane. Variable pitch. So what this thing does is it can fly around like a helicopter. When it flies around like a helicopter, the aft propeller blade basically is not generating any thrust one way or the other. The blades are zeroed, so it's just spinning basically, right? It's not moving any air. I mean, it's swirling the air, but that's another story. So this thing can take off kind of like a helicopter, and then what it can do is you can pitch the rear blades on that propeller back there, and then you can zero these blades out. You can zero them. So they basically just kind of sit there and spin. And it auto gyros. So this thing can pitch, make a ton of thrust, and these things basically zero out their position. When they zero out their position, they work like wings. Yeah, when you zero out the helicopter blades. And you don't need to worry about retreating blade stall either, because you have two contra-rotators right on top of each other. So basically when the bottom blade is spinning forward, the other blade is spinning this way, right? You always have a blade that's facing towards the front of the helicopter on both sides, like right there and right there. So you don't have retreating blade stall. That makes it so this thing can go insanely fast. These things, when you're in plane mode, basically they don't cut the drive to them, but they don't do anything. They just zero them out. They zero the pitch, and those things work like wings on an airplane. And then that thing down there is designed it's a pusher propeller blade. So you increase the pitch on that, the thing goes forward. And then it flies like a regular airplane, and the helicopter blades are its wings. Helicopter blades are the wings. Flies exactly like a C-17. Same, well, not exactly, but the same idea. The helicopter blade's on the top. The C-17 has the wings attached to the top. Same thing. The center of lift is above your center of mass, and it works like a freaking airplane. What the hell? Okay, that's a thing. Nice. So, Blue Thunder versus Airwolf. Airwolf. Have I flown the DCS Huey? I have, Barak. I crashed it a lot. So, this thing can distribute more power to the rear engines and basically zero out these top engines. I think there's a clutch in it, but I'm not sure. I think it's more just pitch. It's constant drive, but this has that synchronizer and everything, like I said, in it. All that stuff that the Chinook has is somehow crammed into this area, right? And then there's another drive shaft going out the back that goes to a variable pitch propeller. That makes it so the SB-1 can fly like an airplane. And the propeller, the helicopter blades become its wings. That's the wings. It's using a similar principle to an autogyro. An autogyro is basically a helicopter, right? Same idea, right? But there's no engine connected to this top blade here. All you have is a propeller, the engine connected to this propeller blade back here. Now, the top blade might not have any drive, but it does have a swash plate like a regular helicopter. But basically, the autogyro uses a spinning helicopter blade as its wings. And you get this out onto the runway, you throttle up the backwards facing propeller, it goes forward, and because it's going forward because of retreating blade stall, right, it'll spin the blades. And then the blades are just auto-rotating. It's just using the oncoming air to power it. So this thing can take off and it'll fly around like an airplane, and the helicopter blade spinning on the top that's the wing. Those are the wings. Like a regular airplane has big wings. Those are the wings. The SB-1 can autogyro like that, and because of that, it can go as fast as an airplane. That, I'm telling you, that's the new hotness, man. This thing here, let's see if we can find some footage of it. How the Defiant turns in a hover. To turn wide while hovering, you increase collective on one and decrease collective on the other. The difference in torque turns the body depending on which rotor has high collective. Cool. See? Look, it's got to have a clutch. You can disengage the propeller. And if it can disengage that rear propeller, I know it can disengage these blades. So this thing auto-gyros at high speed. The helicopter blades aren't powered.
It has phenomenal hover performance. It has rapid maneuverability, crisp control response due to the rigid rotor, and it has high speed with the pusher prop that enables that Army aviator to do the full spectrum mission.
This isn't a new idea. Yeah, it's not a new idea, but there's a reason why the Hg5 wasn't used, guys.
You've got really the best of both worlds. You've got the agility and maneuverability of a helicopter in the low airspeed environment, coupled with the ability to reach the dash speeds of a fixed-wing turboprop.
Those troops, when they're coming into harm's way, when they're approaching that landing zone and people are shooting at them, that you can keep the heat on until the very last minute, and you've got this giant brake in the back that we're able to put negative thrust on that prop and stop on a dime.
Yeah, it's crazy. They can reverse pitch this thing and get it to push air this way instead of that way, because the blades on that rear propeller can go 90 degrees in both directions like that. So they can move 180 degrees. So this thing can be flying, and they can pull the pitch. They can inverse the pitch on that propeller blade, and the thing will go, it'll stop. Because they can basically turn the blades around in the opposite direction. Well, not turn them around. They can kind of do it. It can generate thrust this way or this way. It can go either way, which is crazy. Can it wheelie? Yeah, of course. This thing, okay, so the Chinook, right? The Chinook can land on its hind wheels, no problem. This thing can fly like that. It can hover with the nose down like this. Basically, you have the back propeller blade pushing towards the front, right? The thrust is going, instead of the thrust going this way, the thrust is going that way. And then you have cyclic control on your blades. This thing can hover nose down, which is nuts. No helicopter can do that, except for this. Build this in KSP? Oh.
The ability to maneuver with agility in a low altitude environment. The
Control
pilots
pitch
lie
propellers.
lower,
We've had them on ships for
faster, and
decades. Yeah, of
closer
course.
to the terrain. That to me is a tremendous advantage for the warfighter.
It's crazy. It's crazy, man. The thing is nuts. I want to see videos of it flying around. Let's see if we can find some videos of the thing flying. This thing makes noises that don't sound like a helicopter. It sounds ridiculous. Here, check this out. Come on. Play the noise. Listen to this. Of course they cut the noise. Is that the noise you'd expect a helicopter to make? It's crazy, dude. Wait. Hold on. Let's see. It does, Devils, right? That's that blade. The helicopter. This back blade is making that noise. Are you a fan of Smarter Every Day? Yeah, of course. And see, Swishio, if you're still here, look. It has these tail surfaces, right? And it has these, the horizontal and the vertical stabilizers. Because when it's in plane mode, it needs stabilizers. Like a plane, you need the back part of the airplane, right? But they can't put a rudder back here. You can't put a rudder right there. There's blades that get in the way, and you can't mount it behind the propeller blade. There's blades in the way. So they have the horizontal stabilizers, and then the vertical stabilizers are out on the end of the horizontal stabilizers, kind of like... .905. Same idea. But once again, the 747 has a big wing, right? You have a gigantic wing, and that's what generates your lift. These are just stabilizer surfaces. You don't use these to get off the ground. You use these to make sure you fly in the right direction. That's what this stuff back here is for. This stuff is to lift it up. But with the SB1, these are your wings. Those are what generate lift. And then you have the back, you have kind of the run-of-the-mill airplane back there. You horizontal stabilizers, rudders, no problem. Regular airplane. And also they have a V-stab going out the bottom, by the way, which is pretty cool, man. Look at that, 236 knots. Man, I bet you that thing kicks up a lot of dust with those contra rotators. Airwolf still looks cooler. Dude, Stolfar, this is literally, that's what Airwolf could do in the show. This thing can do what the Airwolf helicopter did in the show in real life. That's what's nuts about an SB1. It can literally do what Airwolf does in real life. You know? I mean, I don't know why they're just, oh, you can work in confined areas. You know, most helicopters can do that, Lockheed. I'm just putting it out there. I'm just putting it out there, dude. Most helicopters can do that. The Bell 222 helicopter is Airwolf. Yep. Could you actually build this in KSP vanilla? Guys, I've made it. Somebody said build it. I've already made this thing in KSP. Yes, it's ridiculous. Yes, it works. Oh, it works great. Yeah, I'll show them to you. I want to play KSP today, so maybe we'll do a little bit of a helicopter dive in KSP today. Not literally. Like, I mean, maybe if I break the thing. Turns out that the control systems, you know, those things have a digital control system, and most my helicopters, because they're an analog KSP. Yeah, it turns out they're a little hard to control when you're, you know, trying to control everything. Mi-26 carrying a plane underneath it. Is that the one where it carries the Tu-154? Yeah. Yeah, see, the Russians went ham with helicopters. Helicopter's a Russian idea, guys. It really is. They do some insane stuff. Look at this. Watch, so that's the Mil-26. The Mil-26 is the biggest helicopter in service today. It's a Russian helicopter, and it lifts things. A lot of things. Mil-26s they're not that fuselage right there. That's not the size of a C-130, but it's almost the size of a C-130. It's close. They're bigger than an MH-53, and you saw me walking around an MH-53. It's the size of a Greyhound bus. Can it lift more than the Sky Crane? Yes, way more. Geek, yeah. Dude, a Sky Crane would look like a Huey next to this thing. That Mil-26 is gigantic. Look, it lifted up that Tu-154. Here, I'll show you. Yeah. You want to see the size of this frickin' thing? So, you know, I could show you a bunch of pictures. Let me find the right one. Oh, yeah. There you go. Here we go. Here's a good one. There's a Mil-26 next to a 206. A Jet Ranger. Don't you ever talk to me or my son ever again. That's the Bell 206. So that Kiowa that I showed in the Pima footage, yeah, there it is. Mil-26s are huge. They're gigantic. This is a little, see, it's Russian dad and Russian American kid. Yeah, Mil-26s are big. Victory. Hey, big boy Matt, give this up to Joe Bob. Thanks, man. Appreciate it. Victory. Mil-26s are bigger than an MH-53 and a Chinook. It's bigger than both of them. This is the helicopter that can lift the most. It has the record. It is ridiculous what that thing can lift. Yeah, here. Look at the people standing next to it. Yeah, they're big. Very big. Yeah, exactly, Pythos. The turbo shafts on this thing are insane. Yeah, they're nuts, dude. Yeah, exactly, Semi. I know about the Mil-12. So the Mil-26 is derived from, oh, what was the helicopter that came before it? Yeah, it's derived from the Mi-6, which is kind of an older version of the same idea. It's derived from that. And the Mil-6, believe it or not, is kind of influenced from the Mil-12. You remember when I said that the Mil-26 wasn't as big as a C-130, but it almost was as big as a C-130? Well, the Mil-12 is as big as a C-130. Yeah. Yeah. Yeah, the Soviets wanted something that could... I mean, you're not going to build an airport out in the middle of Siberia, right? Like, why? Like, what's the freaking point? So they wanted something that would be able to move stuff out there, but not... like, not have a, like, have to build an entire freaking runway. That's why they built this thing. Also, thank God the driver is okay. Okay. Oh. Well, that's not ideal. Yep, Bandit, he's flying through the air. That's not good. Well, that's good. I'm glad he's alright. Kind of off topic, but I just got an 18-hour shift and wanted to show you more pictures from your job. Let me see. Ooh. Oh, yeah. That's cool. Yeah, Matt, let me see. Here, let's take a look. Oh, a slurry treatment plant. Cool, cool. Yeah, you've showed me this briefly before, right? If I'm remembering correctly. Oh, dude. Yeah. Yeah, I remember you showed me this into the control panels, and I'm like, oh, this is dope. Oh yeah, Hein? Really? Yep, there's your control systems. Or well, you're reading the telemetry from the plant right there. Oh, this is cool. Matt, I would nerd out in here. This is too cool. They're making concrete in there, boy. The Mill 26 actually lift twice as much as the Sky Crane. Geek, 26s are insane. I've never seen one in the wild. I've seen a Sky Crane. I've touched one. Touched one at Pima. But yeah, 26s are nuts. But don't get me wrong. I like my Sky Crane too. What's a slurry plant? Creates concrete slurry, man. It's like a... Matt, okay, so I might not have this right. Please refresh my memory. It's a concrete plant, basically. Treats slurry that's used in tunnel mining. Oh, okay. Pumps treated slurry to the tunnel boring machine. Matt, I have a question then. Okay, I got a question. Do you take the slurry from the TBM and make it into concrete? Or do you just treat it and then use it for something else? Yeah, DJ. Bandit just showed me. But just happen. It is. Yeah, it could happen tomorrow. Yeah, geez, I hope not. Yeah, Bandit, I know that slurry in the context of TBMs, that's the muck that that's left over from digging out a tunnel with a TBM, right? Probably depends on what material you drill through. Yeah. No, the material that the TBM mines is moved through the slurry. Then we remove the material from the slurry, and then that material is then trucked away. Yeah. Because, yeah, Matt, don't they need to, like, spray water? You spray the slurry at the cutting faces, right, to keep them cool so they don't overheat? If I'm remembering right, like, I could be pulling this out of my tail. The one in the fence or the other? I'm not sure, DJ. Let me click it, dude. Matt, that's right? Yeah, okay, cool. Yeah, so it's the coolant. The slurry is the coolant. Coolant. That's cool, Matt. This is like Stationeers in real life, dude. I'm sitting here looking at this. There's a motor, and that motor's turning a pump. That's a fluid impeller right there. I know what that looks like. Main 1,200 cubic meter per hour pump street slurry to the tunnel boring machine. And all this is made on site, right? This is on the site of where you're digging, yeah? Yeah, Geek, it's like when you're machining things. You know, if you're on a CNC machine, they spray the coolant at the thing when like an end mill is carving something up, right? And the coolant and the metal flakes get put into a reservoir, and then they separate the coolant from the metal, and they send the metal back to be recycled. Is that Starship parts nearby? I don't know. Well, maybe. Could be. Basically a huge metal earthworm. Yeah, pretty much, yeah. Basically the same when you drill for oil. Cool. That's neat, Matt. This is cool, man. This is all, yeah, this freaking thing's all on site. This is the TBM is like over there somewhere, or at least the tunnel entrance. That's cool, man. That's really freaking cool. Thank you for showing me this. Oh, I know what you's doing. I know what let's do. I saw it over there in the corner. Okay. That's cool, dude. Really freaking neat. Why would a Starship part have a ladder built into it, though? It wouldn't. Those are holding tanks, but they look like starships. Cut material is removed from the slurry so the slurry can be recycled into fresh stuff. Yeah, Jack, yeah, so you have a coolant loop, basically. but the coolant loop exchanges with the mined out material, and that, okay, so this is just a guess. So they need to spray slurry on the cutting face for the TBM, because the TBM is basically, it's a huge drill bit. It's not a huge drill, it's not a drill bit, but it's kind of the same idea. So that gets really hot. So they spray the coolant on it, and I'll bet you, if they spraying the slurry on the cutting face, right, keeps it cool, and it also takes whatever the boring machine is digging up, right, and makes it into a liquid. It makes it into mud instead of just like dirt, right? And that's probably easier to move. You can pump that out instead of like having to scoop it up. Yeah, we have pump jacks all over our job site. Cool, man. That's freaking sweet, dude. That's really neat. Yeah, and then they mix it with the slurry. They keep the thing cool at the same time, and then that's what gets pumped out the back. That's really neat, man. Cool. Thanks for showing me. Our TBM is not as big, but it's the same principle. And what we're looking at here with what Matt is showing is the top side. So that slurry with the mined out material goes to this plant that I just showed you, and Matt separates them. That's freaking sweet, dude. I love learning about stuff like this. It makes me happy.
Rapidly, and is in constant need of more space, even beyond the natural borders of the Yangtze Delta. The Shanghai Changjiang Underriver Tunnel Mega Project improved the link between the Chongming and Changtze River Islands and the Yangtze Delta and the Shanghai metropolitan area, right on time for the World Expo 2010. The two 7.47-kilometer-long tunnels run beneath the Yangtze River, the longest river in China, and were excavated with the largest tunnel boring machines the world has seen so far. These mix shields have a diameter of 15.43 meters. The greatest challenges in this project were the large 15.43 diameter cutting wheel and the adaptation of the machine technology to the geological and hydrological conditions beneath the river. Each of the two tunnels integrates two levels. The upper level accommodates a 3-lane expressway. The lower level provides space for a planned subway line.
All right.
At its deepest point, the tunnel runs 65 meters below the surface. Due to a groundwater level of up to 47 meters above the center of the tunnel, the mix shields are designed for a maximum working pressure of 6.5 bar. Let's take a look at the example of the world's largest mix shield to demonstrate the principle on which Heron Connect hydro shields work. The configuration of the openings and the excavation tools on the 15.43 meter cutting wheel means it is perfectly adapted to the difficult geological conditions. The cutting wheel's 6 main spokes can be accessed from behind the shield under atmospheric conditions to allow the tools to be replaced.
It's an inchworm, dudes. Watch. You see, you have 2 sets of hydraulics. One set of hydraulics is facing forward, the other one's... Actually, I don't know if it's 2 sets. That might be 1 set here. But basically, it stops. The hydraulics push the cutting face forward. Then the cutting face stops. And then the whole machine moves forward. And it goes... Inchworm.
This makes diving operations for tool replacement obsolete.
Oh, nice, Novus. I'm going to read that. Note the stairway inside of this boring machine.
The cutting wheel is driven by a total of 15 electric motors, with a nominal power of 250 kilowatts each, and a maximum torque of up to 39,984 kilonewtons.
$39,000 kilonewtons? All right. All right. Wait a minute.
The cutting wheel is driven by a total of 15 electric motors, with a nominal power of 250 kilowatts each, and a maximum torque of up to 39,984 kilonewtons.
All right. That's, let's see. Let me do some math out in my head. That's like 8 million pounds of force. Yeah, 8 million pounds, give or take. It's somewhere around there. So those motors can push on that cutting wheel with the equivalent amount of force of a freaking 8 million pound block of concrete falling on something. So think about an 8 million pound block of concrete, and if you had a car underneath it. No more car. You have a nice flat piece of sheet metal, right? That's how much force that can be applied to that cutting blade. That's nuts. Is that a lot? Yeah,
there are 3 airlocks.
That makes this thing can generate more force than a Saturn V. Meaning the force being applied to turning that red blade right there is more than the force coming out of 5 F1 engines from a Saturn V. It's more force. That's ridiculous. That is ridiculous.
The center lock is movable and can be linked to the pressure-protected interior of the cutting wheel.
So, think about it like this. If you had a Saturn V that was bolted right here, and your rocket engines were facing here, and it's like a pinwheel, those motors could move the wheel better than a Saturn V pushing on the cutting face. Like this. If you just taped the Saturn V to the side of it, and the engines were pointed up, and you fired the engines, it would create 35,000 kilonewtons. That thing makes 39. It can literally, the Saturn V wouldn't be able to turn it as powerful as all the electric motors combined, which is nuts. That's ridiculous. How many Raptor 2s is that?
19 triple
15?
hydraulic cylinder presses produce a
16?
maximum thrust force of 203,066 kilonewton to move the mix shield forward.
200,000 kilonewtons. Oh. All right. Yeah. 200 meganewtons. That's 3 super heavies. This thing is pushing forward with the same amount of force as 3 Starship first stages. So, like, imagine if you took 1, 2, and 3, so super heavy, right? Like 3 of the 9-meter cores duct taped together like Falcon Heavy, and you attached it to the back of this. That's the equivalent force being used to push this thing forward.
The cylinders brace themselves against the last previously installed lining ring and push the mix shield ahead. The erector lifts the individual concrete segments and positions them precisely for installation.
No wonder boring is slow.
The first gantry is located behind the erector. Due to the machine's large diameter, the backup system has 3 levels, so that it can accommodate the slurry pump, control cabinets, bentonite supply system, and hydraulic pumps.
What a machine, dude.
The segment feeder is mounted on the first gantry to transport the segments to the erector.
Oh yeah, Matt? Damn, man.
The second gantry forms a bridge between the second and third levels.
Oh, it's got a gantry crane built into it. Why wouldn't it?
The third gantry travels on the backup rails, which are laid next to the road element, and then taken up again behind the gantry. The total length of the mix shield up to the third gantry is 135 meters. The mix shield works in 2 phases. The first phase is the installation of a lining ring. Concrete segments are supplied by the segment feeder and subsequently lifted by the erector.
Oh.
In the installation area, The hydraulic cylinders are temporarily retracted in order to provide enough space for the new segment. The segments are positioned with millimeter precision and secured by cylinders immediately after their installation. After that, the segments can be bolted into position. The conical keystone is inserted from the front.
Yeah.
When a complete lining ring has been installed, the bottom segment, which is a retractable module, is put in place in the lower section of the last previously installed ring. It serves as a foundation for the gantry, which can now follow.
It's the tracks. It's the tracks. It's a big
The
train,
lining
and
segments
they
are
just pick a
delivered by
track
special
segment up and
job
put it
site
at the front.
vehicles from the surface to the rear part of the machine.
Huh, that looks like a Kometo.
On the third level,
Interesting.
a segment transport crane moves the segment from the rear part of the machine to the front. The crane is also used to transport the grout container on the first gantry.
Oh, you have to grout? Of course you have to grout it. That must suck. Wow.
The
that
segment
must be
transport
horrible.
crane moves the segments via the bridge of the second gantry to the transfer area of the first gantry. The segments are lifted and turned by the transport crane and then positioned on the segment feeder. The segment feeder moves the segments under the first gantry to the erector and into the
Grout has
take-up
been
position.
the biggest problem? Yeah, Matt, what happens if you're drilling below the water table? You're gonna make a swimming pool real quick.
The excavation chamber is situated behind the cutting wheel and separated by a submerged wall from the working chamber.
Yeah, see? Right there.
The excavation chamber is completely filled with bentonite, and the working chamber is approximately 2/3 filled.
Wait, what's bentonite? I don't know what that is. Is that your slurry?
The two chambers are connected in the form of communicating pipes via an opening in the submerged wall.
Yeah, right,
The filter
Hellbore?
cake is generated ahead of the cutting wheel by pressurizing the bentonite in the working chamber with compressed air. The soil and the
Okay, I
groundwater
got you.
pressure can
Yeah.
reach up to 6.5 bar. Changes in the geology and consequent changes in pressure can be compensated by adjusting the pressurization. The excavated material falls into the excavation chamber. Small-sized grains are largely dissolved in the bentonite, whereas stones and debris sink to the bottom. The opening of the suction pipe is protected by a nozzle grid. Two agitators and mobile flushing nozzles guarantee smooth removal of the excavated
See
material.
those two things that are spinning at the bottom?
The excavated material is pumped through the suction line to the separation plant at the surface. Here, the soil material is separated
They use
out
that
and
or
removed
polybore.
from the bentonite suspension, and the clean suspension is transferred back to the slurry circuit.
Talk about an application-based machine. Like, boring machines look ridiculous. It looks like, I mean, I don't know. This looks like something that you'd see in like Total Recall or something. Like, it's like sci-fi. But the reason why it's so ridiculous looking is because it's wholly application-based. Like, nobody's, nobody said like, oh, I'm gonna make tunneling easier. Well, there is one guy that's trying to do that now. But that's you know who I'm talking. But like everything here is kind of because it has to be that way. Like, there's really not, like, how else are you gonna do it, you know?
To provide an optimum flushing process, the feed line supplies several nozzles distributed around the TBM circumference, which can be connected during peak
Actually,
load times.
Matt, I had an idea for how to do this. I don't know. I don't think it would work. I don't think it would work, but I did have an idea for, when Elon first started talking about like boring company and stuff, I had an idea for how to make a boring machine better, but yeah, I don't know. It probably wouldn't work.
As tunneling advances, the feed and slurry pipe connection is extended.
Imagine how freaking
Flexible
hot
extension lines are installed on the third gantry to prevent the pipelines uncoupling after each thrust phase. Sliding shoes compensate the machine's movements. The pipe wagon is released after the final position has been reached, and then returned to the starting point. The extension pipe is then installed in the generated gap. The 6 main spokes of the cutting wheel are accessible under atmospheric conditions. For tools to be replaced, the cutting wheel is halted in the maintenance position.
Look at how big that freaking thing
The
is.
accessible spokes
Frick
allow the
you.
maintenance staff to reach the worn tools and replace them.
Yeah, see, they have a bunch of small cutting faces, so you can, if one chips, if you chips a teeth on a rock or whatever, you can just replace it.
The tunneling team installed 7,472 lining rings, each made up of 10 segments. 27 million cubic meters of soil were excavated for the tunnel and had to be removed.
Okay.
With top daily performances of 26 meters of tunnel and top monthly performances of 142 meters, the McShields drove the 2 tunnels accurately in a period of 20 months.
Oh, that's cool, geek. Ewoks makes bits for that. Wait, who does... Wait.
The 2 largest McShields in the world,
Text me what...
with diameters of more than 15
who does she
meters,
work for?
set
Wait a
new
minute.
standards in tunneling.
Oh.
This project is an example of successful large-diameter mechanized tunneling. McShield technology is a convincing solution for long and deep river crossings, since it is able to cope with loose soil and high water pressure, even for large-diameter tunnels.
Yeah, Ryan, I'd have to check it again, but...
The first breakthrough was celebrated in May 2008. The second followed in September of the same year.
Huh. Matt. Kind of like that, huh? Have you watched The Core? No, I haven't.
Finishing work on the
See your
tunnel
last
started
two.
1 year ahead of schedule. The 2 tunnels were inaugurated and opened to traffic on October 31st, 2009.
Cool.
9 months ahead of schedule.
That's cool, man. Hold on. Let me see these videos here. Let me take a look. We went from Chinooks to boring machines, but hey, you know, that's cool too. Yeah, Bill, I know what you mean, right? Discord. That's what I thought, geek. Yeah, that's what I thought. That's what, dude. I was like, wait a minute. I know who makes those things. I know who makes those parts. That's cool. Oh yeah, look, they're lowering the segments right there. And there's the guide rail. Oh, that's freaking cool, man. Looks like the Millennium Falcon. A little babby boring machine. Her name's Rachel. Oh yeah, there's your hydraulics. Yeah, Matt, dude, I don't know, man. I had an idea about a boring machine. I had an idea. I don't know if it would work. So, like, I don't know if I want to say, because it might be a really good idea. They do 0.8 meter TBMs. Oh, cool, Geeson. Like, because once again, Elon was talking about, like, a quicker way to bore the tunnel, right? Copyright it? Keep it to yourself just in case. Alright. If it worked, they would have done it already. I don't think anybody would think about it this way, Laserman. I really don't. Here. I'll give you a hint. I won't say what. Like, I've looked at a lot of boring machines, right? I've looked at a lot of different boring machines and how they work and what they do. Let me find... yeah, I don't want to show... yeah. Here. Here. There you go. Yeah. Wait, hold on. Yeah. That's an American answer to digging. Shoot it. That's not the solution, but yeah. Oh yeah, look at that little he's a little micro bore. Oh, look at that little thing. Oh, look, it's like a little graboid. Look at that. Yeah. Look at this thing.
Throughout the world, pipe jacking and microtunneling are becoming increasingly important for the installation of new service pipes and sewer pipes. The Herrenknecht AVN series, introduced in this film, has been deployed successfully on every continent. The advantages of the pipe jacking and microtunneling process are evident, especially in urban city areas. Pipe jacking causes minimum disturbance along the construction route,
Better
so
call
there's virtually
DigSafe.
no disruption to the flow of traffic or any impact to the local economy. In contrast to conventional methods in such construction projects, pipe jacking and microtunneling has an environmentally friendly method and helps to conserve protected landscape areas.
See a little baby.
The following animation shows the installation of new sewer pipes DN600 in an urban crossroad with dense traffic.
Yeah, that's Steiner. Yeah, that's
The
an
whole
interesting
construction
idea.
site can be located in a way that only one lane is blocked.
Dude, look at that. It's like what Astra's launch pad is to rockets. This is just fit it in a little shipping container. It's cool.
In our example, 150 meters of sewer pipe are to be jacked from the launch shaft to the reception shaft.
Pipe jacking and these microbore TBMs are slowly putting my company out of business. Luckily, they still use their steel liner plates to line microbore tunnels.
At the first stage, the area around the starting shaft is cordoned off to divert the traffic. Due to the compact design of the machine and the small diameter of the starting shaft, there will only be minor disruption to the traffic flow. In this case, the starting shaft consists of a round shaft of reinforced concrete with an inner diameter of 3.2 meters. The compact jacking frame is then placed into the starting shaft, and the slurry discharge pump is mounted on a platform adjacent to the jacking frame. The operating container with the control panel and the hydraulic
There you go,
power
Matt.
pack
Yeah.
is located on the top
It looked like a
rear side
bunch
the
of
shaft.
connexes stacked on top of each
A
other.
pipe stock is then established and maintained in front of the shaft to feed the shaft crane. The slurry feed pump and the slurry discharge pump are connected between the shaft and the control container, and then connected through the separation plant to form a closed slurry circuit.
Wait a minute. How the frick does...
The AVN 600 machine consists
I see
of
what it
several
does.
segments.
Pipe jacking. Oh, okay, I get it. I get what this
The
does.
sleeve shaft with 3 bolt holes connects the cutting wheel with the drive unit.
This would be hard to
The
do
conical
at
crusher
scale.
situated in front has reinforced cutting bars and is provided with nozzles to inject the
Oh,
fresh
that's cool,
water.
geek. Hell yeah. Neato. How low can you lower
The drive
min-miss
shaft, which
before
is
gravity
connected to the
pulls you
cutting
down?
wheel.
It's not about altitude, Coleman. It's about speed. Don't, on min-miss, what is it, guys? Don't go below 150 meters a second, I think it is. If you go below 150, you're coming down. It's not about speed. Distance has nothing to do with it. It's all about velocity.
In a tapered roller bearing. 3 hydraulic motors transmit the rotation via the gear rim to the sleeve shaft and the cutting wheel.
Hydraulic motors.
The 3 steering cylinders enable the operator to correct the direction of the tunnel boring machine, as well as control the alignment of the machine in curved drives. Therefore, the position of the cutter head is continuously updated with the help of the laser guidance system.
Yeah, there you go, Cyanide.
To ensure
Coleman,
AVN 600
see
has
what
a
Simon
smooth
said.
method of excavation, the machine has 2 integrated water circuits. The standard water circuit supplies fresh water to the analyse via 5 hoses fixed to the inner side of the bulkhead.
Yeah, well, but it can frickin' steer.
Several boreholes branch off from the analyse, which supply the chamber situated behind the conical crusher. The fresh water is continuously pumped through the conical
I'm
crusher
gonna tell you what
chamber
you could do with
and
an
sucked out
underground
through
tube.
the boreholes of the sleeve shaft and transported back to the surface with the shaft slurry pump up to the separation
Yeah,
plant.
okay. Okay.
A second hose supplies the high-pressure nozzles used in the conical crusher. These nozzles avoid clogging and agglutination of the crusher chamber in case of cohesive soils.
Yeah.
They cut the clay in the crusher chamber with 250 bar water pressure and break up the material. There are also 2 nozzles that are directed to the front part of the cutting wheel.
Oh, look at this thing!
This totally depends on the geological situation, as the number of nozzles can be increased.
I don't know
The
why
water
that's
coming
funny.
from the nozzles is mixed with the water of the slurry circuit.
I'll show
And the
you a
excavated
conical
material
crusher.
is transported to the surface. The cutting wheel
Yeah,
excavates the
Geeson, I know what
material
you
at
mean.
the tunnel face, which is pressed into.
You know who could use one of these, Geeson? Colin Furs. Colin Fursey could probably do good with this.
The crusher chamber and is grinded into the appropriate grain size by the spokes of the cutting wheel, which operates
I don't know
on the
why.
same principle as
Yeah.
a coffee grinder. Large stones are
Wait a
crushed
minute,
by
can I
the
hear that
dip
one more time?
and is grinded into the appropriate grain size by the spokes of the cutting wheel, which operates in the same principle as a coffee grinder.
Yeah, okay, cool.
Large stones are crushed by the discs of the cutting wheel. Sometimes fragments are being driven out to the surrounding soil. Stones falling through the openings of the cutting wheel into the crusher chamber are crushed by the reinforced conical crusher and the spokes of the cutting wheel, and afterwards transported together with the slurry water to the surface. The material is picked up in the slurry circuit and transported to the separation plant through the central slurry discharge hose.
Yeah, Anko, you're right.
The slurry discharge hoses and the slurry feed hoses pass through the center
Oh,
of the
nice,
jacking
Reaper.
pipes via the jacking frame up to the surface. The slurry discharge pump removes the excavated material
Dude, those
and
things are
pumps it up to the
huge.
separation plant.
Guys, I'll be honest, this is kind of close to the idea that I was thinking. It's kind of close. Yeah, this is similar, but it's not the same, but it's similar. That right there. That's yeah. That's similar to what I was thinking. So
The material is picked up in
the
the
idea
slurry
I have
circuit
might
and
already be a
transported to the
thing.
separation plant through the central slurry discharge hose. The slurry discharge hoses and the slurry feed.
Actually, no, the drill head is just made out of steel. It's the cutting face on the drill. If we go back to here, so see these solid pieces right there? That's the stuff that's made out of like tungsten and it wouldn't be, well, no, it could be tungsten. It's some hard metal. It's these things. Those are the ones that are made out of strong stuff. This is just steel.
Transported together with the slurry water to the surface.
Yeah, carbide and what's the other one?
The
Cobalt?
material is picked up in the slurry circuit and
Best car.
transported to the separation plant through the central slurry discharge hose.
This is the way. No, they don't use diamonds. Too expensive.
The slurry discharge hoses and the slurry feed hoses.
Your plan is this,
pass
it's
through
just
the
way
center of
bigger.
The jacking
Yeah.
pipes via the jacking frame up to the surface.
Oh, okay.
The slurry discharge pump removes the excavated material and pumps it up to the separation plant.
Yeah, okay, I see it. And this is the part I want to see, Matt. Hold on one second.
The product pipes are lowered into the shaft one after the other and connected with snap connectors. The jacking frame works in 3 stages. After approximately 1/3 of the maximum piston stroke, the jacking arms return and the main thrust ring of the jack can advance further. After jacking the product pipe, the connecting hoses, which connect the TBM to the container, are disconnected.
Bro.
The jacking frame is returned to its original position, and the next
Cubic
product pipe
boron
is connected.
nitride. Oh, neat.
This procedure
cool.
is duplicated again and again until the whole drive length is completed, reaching the reception pit. Crossing pipes and buildings are no problem with this technique.
TGV
as they
down
can
there.
be easily overpassed or undercrossed.
This actually freaking works.
Thus, the machine arrives in the reception shaft exactly at the planned coordinates.
Yeah.
The drive is continuously monitored by a laser measuring system.
That works? How does that do that? What? No! No! No, Freb! What the hell are you doing out here, Freb? No! No, Freb!
This laser system is positioned in the starting shaft, meeting the target, which is installed in the
Just push the
cutter
tube through... Yeah, just push the tube through some dirt, Fivehead. Yeah, obviously, like... Yeah, stupid. 95, why didn't you think of that, bruh? Like...
The laser determines the reference axis.
Yeah, that's right.
The laser
yeah.
target identifies any deviation which may occur. The coordinates are transferred to the steering computer in the container and visualized on the screen. Any deviations in position can be corrected by adjusting the steering cylinders at the push of a button on the control panel.
What the frick?
The length of the tunnel is recorded by a metering wheel. This information is transferred to the control panel, allowing the operator to visualize the location and direction of the machine cutter head at any time.
We were just looking at that video, or something similar to it.
In our example, the total of 150 meters of new pipes could be realized with only a minimum of disturbance in a difficult infrastructure.
The boring machine knows where it is. It knows where it is because it knows where it isn't.
The conventional
Yeah, Fractal, right? It's a little baby boring machine.
Throughout the world, the company, with its headquarters in southern Germany, is the only supplier offering the complete range of tunneling machines.
Oh, of course it's German made. Leave it to the Germans. Of course they made this. It's super complicated. Yeah, why wouldn't the Germans make this? What, you think if they wouldn't make it like this? This is the only way to do it. Yeah. Leave the complex machinery to the Germans. Yeah, will do. Jawohl. The company's just around the corner from where you grew up, Jock. That's cool, man. Yeah, und ja, ist Deutsch, yeah. Because we know how to do it. Never said that was a bad thing. Das ist gut, yeah. Leave it to the Germans to make something boring. Only the Germans could make something so ridiculously complicated and cool, boring. Yep, Ando, you're right. Yeah, it's a good call.
Discovery, go at throttle up.
The Germans are like, 9. That's not funny. That's not funny. Shut up. That's cool, Jake. Yeah. I quit. Wrecked Sawyer. Nine. No, seriously, that's cool, man. I love heavy industry. Heavy industry's freaking cool. I don't care where it is. Yeah, man. Matt, I'll have to talk to you about that, dude. I'll have to talk to you about my idea. The pipe jack is kind of what I was thinking, but it's kind of not. Yeah, you're damn right, Shrub. There's so much cool stuff out there. Like, guys, I wasn't really expecting talking about boring machines during space news today, right? Like, I wasn't expecting doing that, but... You know, like, sometimes it's cool, dude. Somebody could see that and be like, damn, dude, that's really neat. I want to do that, you know? And that's worth it, dude. Like, that's why I don't mind necessarily going on tangents during space news and whatnot. Like, talking about planes, helicopters, whatever. Because there's so much cool stuff out there. You know, and if somebody sees that and they're like, wow, that's what I want to do. I want to do that. You know, then it's worth it, you know? Oh, yeah, Envy? Right on. Tech News, or EJ Tech Talks, yeah. Greetings from Bagger288. The Bagger's a beast, Toto. Love that thing. This just turned into machine news. There's been no space yet. Yeah, no, sorry about that. Pipe jacking doesn't work with large tubes, unfortunately. Da Vinci, believe it or not, the pipe jacking part is not the part that I was looking at. Did you see how that boring machine, the pipe jacking boring machine, not the pipe jacking part, but it had a tapered it had a conic tapered, like, area behind the cutting face, and that ground up everything. Yeah, that's the part that's similar to what my idea is. Not complaining. It's been super interesting. Yeah. Can I please recommend something relevant? No. Yeah, of course, man. The Bagger 288 is cool engineering, but that hole, it is a shameful scar on Earth. It's mind-blowing. Yeah, I mean, I guess. Could always fill the hole in. So, is there any space news? Not really. I mean, I have an update on the Artemis engine controllers, and I kind of want to read that off stream. Somebody linked it yesterday. There's just Starship updates, and Blue Origin is going to build another huge building. There was another permit that came in for Blue yesterday. They're going to build another huge building next to that heavy road that I told you guys about in yesterday's Space News. And then the Antares launched this morning. Also, SpaceX postponed it. The launch is now on Monday. The Starlink launch. It's not on Sunday. I'm pretty sure it's just because they want people at SpaceX want to watch the Daytona 500. Hell yeah, boy. You gonna make a building to space? Just Starship updates. Yep. No SLS news? No, they've gone a little bit quiet, but I have a news about... They figured out what was wrong with the B channel on one of the RS-25 engine controllers. How it went dead and they had to replace it. There was something about that. Numerous tests were done on the faulty Engine 4 controller, determined to be the cause to be a faulty memory chip. The device is used only during the controller startup sequence and has no impact on controller operations beyond that point. There is no indication of faulty memory chips on the other 3 engine, and therefore no related constraints to the wet dress rehearsal or launch. Interesting. So, the BIOS broke on the engine controller. Good to know. It's not the BIOS, but it's the same idea. The RS-25 didn't get to post, guys. When is the next Falcon Heavy launch? SF-44? Serious? Sometime this year. The Falcon Heavy is ready. There's a Falcon Heavy sitting down at the Cape, just waiting. It's waiting for its payload. It's been waiting for its payload for a couple of years. That guy is playing Galaga. NASCAR wreck. Let me see this, DJ. Overclock failed. Press F1 to enter setup. Yeah. Let me see.
Tom's gonna have the biggest energy here.
Nobody was hurt from this, right? Because if someone's hurt, I'm not showing it on stream. I have a rule about that. Like, nobody's dead, right? No. All right. Let me see. You gotta be careful with this kind of stuff. This kind of stuff you can get DMCA'd. All right, let me take a look.
Energy here. 21's gonna come with a huge show.
Okay, second of all, the people who watched us race Daytona last night, and the people that got introduced to NASCAR and how ridiculous it is, consider that. Did you guys saw how nuts it was with like 3 or 4 cars next to you? Try 30. That's what the real sport is like. It's nuts, dude.
They are 2 and 3 wide.
Oh, what are you doing?
Austin Hill on the 21. Big crash. Up and over.
Oh my God. That's nasty. So, where's the... Don't these things have the... Oh, it didn't do it. Oh, that's bad. Oh, man. You know, something came off right there. Let me see this. How is he alive? Because there's a crash. There's a freaking... It's an armored box, basically. So, yep, that car's flying through the air. That's not good. That thing is fully off the ground. Okay. Fellas, alright. Just a little bit of word here. these cars are going really fast, right? They're going fast. Little bit of a word on physics here. That car weighs like 4,000 pounds. NASCARs are very heavy. They're heavy because they have an armored box because, you know, you don't want to hit the wall with no roll cage, right? Yeah, Hellfish, I'm getting to that. So, 4,000 pounds. So, for our Euro friends, that's like 1,800 kilograms. They're heavy, man. They're really heavy cars. That's on purpose because when you crash, you don't want to get liquefied, right? The guy walked away from this. They're very heavy, however, that car generated enough lift. It generated enough upwards lift to be able to lift 4,000 pounds. That is generating more than 4,000 pounds of lift. Because that car is fully in the air. So, literally it's generating enough lift to make the TWR, thrust in this particular case being force that is generated by lift, to move this car about 20 feet up in the air. That's how much force is right here. And then gravity does its thing because cars don't make very good airplanes. Okay, yep. So the back of the car went into the fence. I mean, the car is still flying through the air. So the back of the car went into the fence. You see that? All that? That's the fuel. That's fuel just being splashed everywhere. Just thought I'd let you know. And then it seems to spin around. And then it shears the front of the car completely off. You see that? All that smoke right there? That's the coolant system depressurizing. So that's good. So, oh, the engine. Oh, that's the engine. Yeah, okay. The engine came out. Yeah, that's the motor right there. And the car is over here. Ejecto engine, cuz. Yep, okay. And then that's the fuel lighting on fire. That's good. Yep. Engine and transmission right there. That's good. Nobody hit that, did they? Oh, yep, someone did. Oh, fuck. Oh, 2 people hit it. Holy Nikes, that's... Oh, my goodness. Oh, my goodness. Oh, yeah, what the frick, dude? And because the fuel tank popped, it doused everything in fuel. That's why everything's on fire. Oh, my God. Holy... Eject the warp core. Quite literally, the NASCAR equivalent of that. Holy shit. Man, you gotta be kidding. What the... Yeah, the guy's alive. Guy, if the guy was dead, I wouldn't be showing it. You're telling me he gets out of this? He gets the guy... Oh, yep, he's fine. Yep, he's moving around in the car. What the frick? What the frick? How about the guy that hit the motor? Tax Slayer! Or Car Slayer. That was the last lap? That's hardcore, man. That's worse than Newman's... Dude, Green, that scared me. Newman's crash was not... I thought he died, dude. I thought we watched him die. I'm really happy he got away from that. Alright, let me see one more. Guys, we gotta be careful about showing, like, Fox on stream, okay? Like, I gotta make sure we're looking at it in a critiquing sort of way. It has to be transformative. No. Oh, jeez. Oh, yep, that's the engine right there. Oh, that's terrible. That's terrible. No. Oh, my goodness. Freaking engine. It ejected. Eject the warp core. Oh, there's the diff. Oh, yep. Nope, the diff's on fire. Yep, it rolled away. Okay. Yep. What the frick? Man, did somebody hit the damn motor? This is why you guys are trying to get my attention. Like, oh no. So, for the non-NASCAR people, this is called a catch fence. The catch fence is designed, it's basically a cheese grater for the car. It's designed to, like, think of like it does what a Kevlar vest does to stop a bullet. So if a car runs into it, it's designed to bend, but it also has a bunch of like bolts on it sticking out, so it's designed to shear the car off. So if you drive into it, the car breaks, not the fence. So you don't fly into the stands. You don't want to do that. And it's designed to rebound like a Kevlar, like a bulletproof vest, and push the car back onto the track, because rather push it back onto the track than into the stands where, Le Mans in 55, they could have used the catch fence. Yep. There's no end. Yep, there's the motor. The motor's over there, and that guy hits it head on. Oh, dude, he hit it and the radiator croaked immediately. Look at the coolant system depressurize. The radiator just said, all right, no. No. Yep, see, there's the diff. There's the rear differential. I saw that thing rolling away in the fire. Yep, up there. Oh, no. Oh, it stayed with the car. Look at that. That's what it's supposed to do. How in the absolute frick? Yeah, I've like him. We'll have time. Dude. I mean, but here's the thing, fellas. Okay, this looks bad. But, guys, that's what the cars are designed to do. They're designed to shear off. It's designed to... The motor, like the motor hitting it, is designed to shear. That's designed to break and absorb some of this force before the part where the driver does absorb force. Because if the cage where the driver is... If force gets to that, you had a really bad crash, and that's when people get hurt. But the car is designed to break apart. It's like a crush core. The whole front of the car is a crush core, like on Falcon 9. It's the same thing. It's the same idea. So this looks gruesome, but believe it or not, the engine took the brunt of the wreck, so the guy didn't have to. The engine basically shearing off acts as a shock absorber, and same with the diff. The diff is supposed to come out too. The whole back of the car is supposed to break off. That's the whole point, because it breaking off absorbs that force. You see how the whole front of it is bent? It's designed to crush. Yeah, Bandit, I always look at the driver, dude. At the very end here, you can see him moving around in the car. That's always what I look for, man, because, yeah. You look to see that the helmet is moving around, because if the helmet ain't moving around, that's when it gets bad. All I can think of is, the engine. How's the engine doing? Let me see. All I can think of is Imola in 94. When the guy's like this in the car, then something's wrong. Let's see. Oh, that ain't too bad. Hey, that's not bad. I told you Chevy makes a good engine. That's okay. Dude, I bet you it runs. See? Chevy makes a good motor. Your headers might be a little messed up, though. I think the exhaust header is kind of pinched. No lowballers. I know what I have. Yeah, it looks fine. It's fine. What's wrong with it? It's fine. Holy crap, dude. I can't believe that. Put me back in, coach. Light use. Only been raced once. That's... I bet you could use that again. I bet you could use that again. ECR is a GM race motor shop. Well, you know what, Hilness? They did a good job. See? Chevy makes good motors. I've always said that. They do. I'd take it. Yeah, me too, Mutter. Dude, that's crazy, man. You gotta be kidding me. One owner engine, custom built, low mileage. They might make good motors, but they can't make good cars to put them in. Well, yeah. That's a cool... Dude, these things are... They still use a distributor? That's a distributor with a sensor, a timing sensor on it, though, right? Or a crank angle, or a cam angle sensor, right? Yeah. Interesting that they still use distributors, huh? Man. What? Skip to 10 minutes to see the driver walk. DJ, as long as Miat walked, Miat, or is it Matt? As long as he walked away, that's fine. They still use it in the next gen also. Interesting. That's interesting that they go with the distributor with a cam angle sensor in it. I mean, that's... Look, I understand the reason. They probably do it to keep it simple, right? Keep it simple. Make the sport easier and accessible, right? That's the whole idea. But, yeah, interesting. Mayat Snyder. Yeah, Arctic, I'm glad he's okay. That was a pretty horrendous crash. No, Steam, I haven't talked about the new internal combustion engine Omega 1 by Astron Aerospace. I mean, Bandit, dude, that's the kind of stuff I kind of want to do with Tough Enough. So, guys, that thing looks like an old school distributor on a car, but there's a computer inside of it. The computer is sending a signal. I mean, it's a distributor, but it sends a signal back to an ECU. It's not mechanical. It's not a mechanical distributor. Like, it's not points, that's for sure. It's got a camshaft angle sensor built into it. Yeah, you can modernize old cars. You could like retrofit an old muscle car with a computer with the angle with the cam angle sensor. Xfinity still runs carbs. Yeah, dude, that's a Holly double pumper right there. Absolutely. Holly double pumper. They got spacers underneath it. They got a single plane intake manifold with equal length runners. Well, long tube equal length runners on a single plane. Yeah. That's old school, dude. But then again, NASCAR is old school. Yeah, Platinum. Wait, keeping the sport accessible and simple and accessible is an option? Yeah, I know, right? Here's the fence. Let me see, DJ. Yep. I'm telling you, the catch fence is like it's supposed to absorb the impact, but it's also like a cheese grater. It's supposed to shred the car like a cheese grater shreds cheese. It's supposed to do that. Yep. Holy shnikes. That's galvanized steel. But see how they have the wires and stuff? They have the wires with all these bolts in it. Ando, you were wondering about that. That's these bolts and stuff, and the wires are they're just designed to shear the car off. To shear the car apart, let me say. It's sheared galvanized steel. Dude, that's a lot of force. Like I said, that was enough force to lift up a 3,500-pound car. And then that force had to go somewhere. That energy, that kinetic energy had to go somewhere, and it found its way into the pole. But once again, it's supposed to do that. You can see that where it hit it, and it knocked this tube right out of its sleeve. Whew. That's crazy, Arctic. Will that be ready for the Cup? Yeah, of course. This is all modular, DJ. They'll have it fixed by tomorrow. Yeah, you just got to unbolt all the steel wires. No problem. They're probably working on it right now. So wait. What do you mean? What's up, Riv? Safer barrier. Yeah, kind of. Catch fences are a little bit different than the safer barriers, but NASCAR does have a safer barrier. See this right here? This white thing? That's exactly like what Formula 1 uses. Formula 1 uses something like that. And then on the infield, you usually have Armcos, just like Formula 1. And then behind that you have concrete. Do you see this right here? That used to be a concrete wall. In the old days, there used to just be a concrete wall here, and if you hit it, you're gonna feel it later, or you're not. Didn't an engine go through the fence at Daytona a couple of years ago? No, the catch fence caught it, hand. An engine went into the catch fence. Yeah. What you're saying is that the track's fence is the car's comfort zone. Well, that combined with the car, it's that both of them have give and take. It's supposed to shear the car off, and it's supposed to absorb the impact and push the car back onto the track. Yeah, Vaxock, like I said, this is all modular. You can move it real quick. What's interesting to note is that something I've noticed, and it doesn't really matter, but these bolts right here aren't galvanized bolts, but some of them have galvanized nuts. You see how these are rusting? And this thing isn't? It's Florida. it's humid. Stuff rusts a lot. There's galvanized bolts here, but there's non-galvanized bolts there. Look at the difference. Galvanized stuff doesn't rust as much because it has a zinc coating on it. That's what this like kind of splotchy stuff is on the post. That's how I knew it was galvanized steel. See that? The little splotchiness? It's a zinc coat. Yeah, the cable was replaced a couple of times. Yeah, if it shears the steel cable, yeah, that's it. See that? That's probably got to be replaced. I wouldn't use that again. They were galvanized, most likely. Yep. Verzinkt in German, if I'm not wrong. It's crazy, dude. What is this Viking? I'd need new pants if I was there. Yeah. Dude, I watched that race. I watched that race live. Yeah, Austin Dillon. Yeah, into the catch fence. Yep. Yeah, that's... NASCAR gets crazy, man. It gets crazy. And these new cars, it gets even crazier, apparently. Apparently, they haven't figured out the aerodynamics. Normally, NASCARs, when they spin around, because if you think about it, right? If you think about it, the NASCARs have, like, the back of the car is up in the air. It has a rake on it, and that's on purpose. Formula One cars do that, too. Red Bull is notorious for their rake that they put on the car. Basically, they get the back end of the car up in the air. It helps you go around corners better. It helps distribute momentum, I guess, would be the right way to say it. I'm probably not saying that right. The NASCARs have a huge rake, right? So if they spin around, what happens is you expose the back end up in the air to oncoming laminar flow. The air goes underneath it and it gets compressed and the car takes off. Now, NASCARs in the past, they have speed brakes that are on the roof of the car. And if a car spun around and the speed brakes they could just flop around. If the car spun around and it got like on the roof of the car and it, they got air underneath them, they'd pop out. And they were speed brakes that were on the top of the car that would counteract the lift that's made from the rake on the car. That thing Miat's car had that, but they didn't work. It didn't work. It freaking didn't work. It shouldn't have done that. You can see them deploy, actually, right before. There's aerodynamics going on here, guys. So, here, watch. The car goes sideways. You could just see them deploy for a second, but they didn't work, which is very interesting. See them right there? Those are passive. They'll only deploy when the car's going backwards. It's because a car pushed him into the air while he spun. Oh, jeez. Poof! That's freaking brutal. Oh my goodness. Dude, and that other car hits the freaking motor. Oh my goodness. Can you imagine just head on the freaking motor going like 180? You gotta be kidding me. I don't think it's much of a failure of the flaps. It's more just getting hit by another car. Yeah. You didn't see that. Where? It's like the motor shot out of the car. It was designed to shear off. That's what it's supposed to do. Watch. So, that's the engine and the transmission right there. See it? Transmission's right there. The engine's up front, and boom! I love how that car that hit it, the radiator immediately explodes. See that white cloud right there? The radiator just went, no. Nah, we're not doing that. We're not doing that. Oh. Looks like a pod racing crash. Poodoo! It's a freaking pod racing crash, man. It's so ridiculous. Imagine a Seto with these kind of physics. Nah, I'm good. Now this is pod racing, yeah. Anyway. Wow, that was a fun space news. Maybe we should just do this. Do deep dives for every once in a while for space news. Just do deep dives like we did a deep dive into helicopters. Maybe I'll pick a date and we won't do a space news. We'll do presentations on different pieces of mechanical equipment. That's actually not a bad idea. Yeah, Impy. Well, that Grosjean's crash at Bahrain. That, I'll say this once, I'll say it again, and Formula One will never admit it. That Armco barrier did not do what it was supposed to do. It was a defect. It was not supposed to do that. You did helicopters earlier? I had a question for helis, but I guess I missed it. Yep. If you ever do deep dive into NASCAR, I'll be there. Missed space news today, but I agree. That's the one. Yes. Guys, that was an Armco barrier malfunction. Whoever installed that Armco barrier that was not to spec. But Formula One will never admit it. They'll never admit it. While we're on the topic of motorsports, have you seen what they've done to Spa in order to bring motorcycles there? Yeah, they screwed around with Eau Rouge. It's Radeon, actually. They made it more like how Eau Rouge was in the 90s, which is kind of cool. Exactly. Armco barriers are designed to push the car back into the track, and yeah, well, Grosjean, the Halo saved him. I don't like the Halos. I think they look stupid. But I can fully acknowledge that without that Halo, Roman would not be with us right now. So I'm cool with it. You know, I think they look ridiculous, but there's a good reason why they're there. Maybe you could explain real fast, how do swash plates work? Flykin, seriously, go back to the beginning of Space News. The first thing I did was got asked that exact question. If you want to learn how it works, yeah, I did a pretty good thing on intro into helicopters and how they work. Yeah, DJ. Yeah, exactly. But I will say that Armco barrier did not work as advertised. And I've seen nothing, I've seen no mention of it from Formula One. They didn't say anything about it. But, dude, I know my physics, and I know what that Armco barrier is supposed to do. It didn't do it. Car's not supposed to go through the damn barrier like this. It's not supposed to do that. Zachary, helicopter mechanic right here. Zachary, I was, in the helicopter dive, dude, I was, first of all, thanks for watching, man. I do appreciate it. And if I say anything wrong, please tell me. I'm not a mechanic on helicopters. I think I got it down, Pat, but I was teaching how a Chinook, a CH-47, has two turbo shafts, right? And it goes into a gearbox that has two inputs and two outputs, and it synchronizes the two outputs because you have to. I showed what happens if the two Chinook blades get out of sync, and there's a video floating around on the internet where the Chinook gets ripped in half because the blades are out of sync. No, I'm saying I am a helo mechanic. Yeah. No, I know. Yeah, no, I got you. Yeah, no, thanks for watching. And no, I'm saying correct me if I say anything wrong, but I was showing how how with a helicopter you have all these moving parts and everything needs to be perfectly balanced. If it's not, the helicopter will it'll just explode. Yeah. Suspension component from the car ended up in the hood of Denny's butt. How the hell does that happen? Hey, they were using grade 8 volts though. H60 Sierra, and yes, they are crazy machines. Yeah. Zachary, I was teaching people how the swash plate works, how it's basically a big Heim joint, and it can go up and down on the main rotor shaft, and how it can twist and turn and go up and down, and cyclic and collective pitch and all that other stuff. And blade RPM, and how if you just yank on the if you yank on the collective, the whole thing will just explode. It's true, because the torque from the blades outweighs the torque from the engine, and yeah, it doesn't like it when you do that. That's an upper control arm crossbar. The 1/8 is an alignment shim. Grade 8 bolt though, Bill. Yeah, that's cool, man. Yeah, Zachary, the helicopters are cool, man. And dude, I cut my teeth on helicopters building them in KSP. And so I had to go read about cyclics and collectives and how they work and how a swash plate works and how like drag links work and how, you know, retreating blade stall and all this other stuff. Yeah, it's you ever thought of playing any flight sims? I do from time to time, dude. I haven't played flight sim in a little while, and it's not out of not wanting to. I figured out that the whole system voids itself if you yank on the collective really quickly because of flying around a Huey in DCS. I was flying the Huey around in DCS, and I went full collective while we were going forward, and the Huey went like this. Whoop! It tried to do it, and then the blade said, nah, no. And so thing whirligigged and flipped over and crashed. Dude, what a gnarly crash. Hellfish. Yeah. That's crazy, man. Cool that they simulate that correctly. I mean, the same thing happens in Kerbal Shrubbery, but the blades don't rip off. Yeah, the whole swash plate, that whole assembly has to be perfect. It has to be perfectly balanced. Everything has to be torqued. Everything has to be oiled. If it's not, the helicopter won't fly very long. I mean, ask Zachary. He knows. I highly recommend the new Flight Simulator. I played Flight Sim when it came out. I have it installed. I haven't gotten around to playing it. But yeah, I actually had real pilots come in here and teach me. I mean, I know my way around a Cessna. And this is not me saying this. I had a airline pilot friend come and teach me how to fly the 152 Aerobat around, right? And he's like, yeah, no, I trust you at the controls. I'm like, oh, well, that's pretty neat. That's correct. I'm an airframer in the Navy, and the bridge and the swash plate is my bread and butter. Dude, if that thing doesn't work, now you have a flying brick. Yeah, no, swash plates are cool, man. I can't, dude. Who the hell even thought of that? Like, I understand what a swash plate's doing, and it's still nuts to me. I mean, guys, once again, I'll show it one more time, and then we'll watch the Starship footage. It's just... What in the absolute balls, dude? Like, how did you... Alright. Ooh, there's a... Here, check this out. Look. What channel is this coming from? Alexander Zubov. Hey, he's got a Kerbal. He's got a Kerbal for his avatar. So the shuttle, pretty much, Geeson, yeah. Yeah, see this whole thing? Everything has to be right. If it's not, if nothing is balanced, like if you didn't torque a bolt down right, one of these things comes out, that's it. Bye-bye. Yeah, see? Look at this. That's what the slosh plate does. Flykin, look at this. Yeah, you go to Sikorsky. That's right, Ingenuber. I talked all about that before. Yeah, Sikorsky thought of it. Nuts. So that's collective right there, guys. See how it is collectively pitching up all the blades. That's a collective pitch. So that's what the lever on the helicopter does. Right there. That's exactly what it does. And then a cyclic will tilt the swash plate. Just like that. And it'll cycle the pitch as the blade moves around. So if this whole thing was spinning, when a blade got to this side, it would pitch, and then when it spins around to the other side, because the swash plate is tilted, there's no pitch over there. That gets the helicopter to do this. You can roll. Show the bridge of the 860. It's large for good representation. Okie dokie. Let's see if we can find something here. I'm trying to see if we can get... Hey, all right. What do we got here? Oh, hell yeah. See? The tail rotor has the same thing. It has something like a swash plate, but the tail rotor only works collectively. At least I think it does on the UH-60. I could be wrong, Zach. You correct me if that's not right. Yep. Look at that. Look at that thing. Look at freaking thing. Are you kidding me? How does that even work? It still blows my mind, dude. Like, I knew helicopters were ridiculous. And then I went and learned how all this stupid stuff works. And now I think they're even more ridiculous. Yep, yeah, you gotta push the pin in, right? Yep, there you go. Yeah. Let's see if there's anything else in here. Hold on. Oh. Auxiliary power. Yep, pretty much just your rudder. Yep. Oh, this looks like fun, dude. I should have done this when I was 18. That looks like fun. Yeah, baby. Yeah, watch. Yep, there's the fuel boom. V-22s can refuel UH-60s. That's why it has a fuel tube out the front. Haha, fun. Yeah. Yeah, no, you know what I mean. Yep, there you go. Look at that. Yep, there you go. They're cycling the cyclic. Now they'll mess with the collective. Yep, see, there it is. There it is. It's a beast. What a nice helicopter. Blackhawks are really, really good. It's a really good design. Also, I like those things that are on the side. But they don't... Wait a minute. Oh, it doesn't have the fun part. Where's the fun part, damn it? It doesn't have the fun attachment. It's just the mount for it. Doom. I found the mechanic. Yeah, so these are mounts for an M134 if I'm looking at that right. These pipes right here are to make sure that none of the shells fly around. It makes sure that the shell casings get ejected downward and away from the helicopter. You sent me something, Mutter? Oh, boy. Oh, Mutter, I can always count on you. Oh, God, that's going to get somebody sick. No, it's not the barrel flanking. The mount's up here. See the way the triggers? The minigun has an electric auger. That's how you fire it. So you have two handles, kind of like two joysticks, but they don't move. Right? You see them right there? One of them engages the auger, so it gets the thing to spin. The other one makes it go. You have to key one with the other. You need two hands to fire a minigun. Well, not really, but in this design, yeah. I'm pretty sure that's how that works. See ya. He's like, deuces. Do not sit. Really? They had to put. Dude, I don't want to know why they had to put that there. Someone did that, didn't they? Yep. Okay. Right. I wanted to cross-train aerial gunner. Yep. Yeah, it says don't sit, which means you can stand on the thing, right? Yeah. Cool. Tell that to Jesse Ventura and Predator. Yeah, they have that one joystick with the carry handle on the top. Yeah. Try to do that with a minigun. Go ahead. Try to do that. It won't work. Newton's third law will, do its thing. Guys, the A10 has a 30 millimeter. Those miniguns, the M134s, are 7.62 by 51, if I'm remembering right. Could be wrong. I think no, 7.62 by 51. It's not a 20 millimeter. There's 7.62, there's 20 mil, and then there's 30 mil. The A10 has 30 mil. That minigun that's on the A10, if you hold that down and fire it for too long, the A10 will stall. Yeah. It'll stall. Well, you'll probably run out of ammo before that happens, but... I would love to. You buying the ammo? Nope. My ammo's staying with me, dude. Good morning from Germany. Wait, forget what I said. Just hello. Oh, Ransenplan. Wie geht's, mein Freund? See last. The music of the video is loud. Yep. Yeah, Sea Stallion. Those are cool helicopters, man. All right, Mutter sent me this. Check this out. You guys want to see a swash plate in action? I still don't understand how this thing worked, but... Yep, there you go. That's cyclic pitch. See how the pitch is cycling as the blade moves around? There you go. There's your cyclic pitch. That's what a helicopter blade is doing when the helicopter is, like, turning or if it's flying forward. You getting sick yet? That's a blade on a helicopter. Fresh grease. Blech. Yep. That's what it does, dude. So this helicopter, that's cyclic forward. So this helicopter is just flying like this. You can also see the flapping that counters the blade stall. Yeah, look at that. Yeah. Oh, yeah. Oh, that's what that does? That's these things. The little bobbers right there going... It's pronounced Frond. Frond? Danke. Danke Sean. Oh god, yeah, I can't watch that for too long. I'm gonna freaking puke. Okay, thanks. I hate it. Please stop. I said thank you, Sean, obviously. Danke Sean. Yep. No, those are vibration dampers. Yep. Be a man and watch that in VR goggles. No, I don't think I will. That made you ill, yeah. Someone stabilize it. Yeah, right. How fast do the blades need to spin to lift off the ground? So, Liam, helicopter blades generally don't need to spin very fast. Seriously. 300, 400 RPM? It's not very fast. But you gotta remember how big the dang blade is. Yeah, they don't go very quickly. I mean, it depends on the helicopter. Every helicopter is different, but they aren't spinning very fast. It's enough to sink in certain cases with a camera's shutter speed. Is it real that there's a Jesus nut on the helicopter blade system? If the yeah, it's the Zachary or Doom or somebody that knows this. The Jesus nut is it's part of the bridge, is it not? I'm still learning myself. Like, yes, there is, but see that nut is just retaining things, so it's not like it's gonna snap off. But yes, long story short, there's one. It's yeah, it could be a Jesus bolt. Yeah. Yeah, it holds the rotor to the drive shaft. Yeah, okay. Yes, there is. I mean, yeah, how else? Like, you know, I'm thinking, like, why would you just have a single redundancy like that? But how the hell else are you going to hold it to it? Multiple ones? Oh, that's just more things that can fail. You know, but then again, I mean... Then again, if you had like 4 of them instead of one big one, right? Like if it was on a flange or something, and you had a bunch of them. What if one pops out? Then the whole thing will shake itself to pieces. What if 2 pop out? Then you're screwed. Like the whole thing will just break. So yeah, I guess 1 is probably the right idea. So basically, a swash plate is basically a plate that pitches and rolls and then translates that angle to the blades depending on their degree in reference to the plate. Correct. Yeah, pretty much, Flykin. That's how helicopters fly. Yep. That's because if it breaks, you're gonna see Jesus. Yep. That was a fun dive into helicopters, dudes. I enjoyed that. Does the Jesus nut have a cotter pin? And do they call it a Baptist? That was good. That was good, Iger. Got a good chuckle. Yeah, there you go, satellite, right? Yeah. Okay, gotcha. I was wondering because I want to make a realistic helicopter in Gmod. Have fun with that. Freaking helicopters, man. So, somebody did ask how drones work, and I think we'll... Maybe I'll save drones for another day. Drones are way simpler. They are way simpler than a helicopter. Really, it's not yet. No. No swash plate, no nothing. We've made drones in KSP as well. The SB-1 Defiant reminded me of the Eurocopter X3 program that was canceled, but an interesting heli with a top speed of 293 miles an hour. Oh, basistas. What the hell? Oh yeah, look at that thing. Chat, look at this thing. I have the Starship footage for the day teed up, but... Achtung, Liebe. What the frick? Whoa! Yo, that's sick. Whoa! Damn! Yo, okay. It goes horizontally through the mess. Interesting engineering. Yeah. Forget the drones. How do tailless aircraft fly? It depends on the airplane, dude. It's like an autogyro, but reversed. It's evolving, just backwards. Huh. Yeah, that kind of works like the SB-1, dude, now that I'm looking at it. Yeah. Whoa. What the frick? Alright. I already talked about the SB-1, Zonic. That's cool. That's a cool design. Yeah, you could do a lot with that thing. That's really neat. Anyway. I just tuned in. That was a X3? Tail rotor is replaced by differential thrust. I think so, Bill. Yeah, that would be my guess. Are we going to play KSP? Tee up the Starship footage for the day, and then yeah. Maybe we'll mess with some helicopters in KSP. I mean, we're already here, so... I don't know. Maybe we should. Yeah, that's... Oh, golly, that's cool. Look at that thing. What is it moving? Oh, word. Neat. Alright. Alright, let's see. So this footage is coming from our buddies over at NSF here. Make sure you go over there and sub to the YouTube channel. Alright, let's see. SpaceX is doing tests on the plumbing for the pad here. How can you have a tailless fighter, though? I've really never seen a tailless fighter, Rice, but if you can give me an example, I'll tell you how it works. I dare you to make a helicopter with stowable blades and a supersonic afterburner. Oh no. 2020, I saw what you just did. HO-229. We'll make that's a bomber, not a fighter. My phone just went off with... Yep. I know what this is. Yeah. I was waiting on this game. You don't... Oh, no. Oh, why would you do that? Why would you do this? Why did you leave me? Why? Why would you do that? Damn it. I was waiting on... I was purposely avoiding that game, dude. Because I'm worried that if I bought it, you know what would happen. Oh, yeah, Element? Damn it. I like trains. Let's build the big boy. Oh, no. Oh, no. What are they stacking over there? Booster, huh? They have Ship 22 stacked there on the right. Looks like they're stacking booster segments there. The big boy's not being added, sadly. It's either booster 7 or 8, Kev. I'm gonna. I think it's 8. Here, let me check the. Foot. Yeah, it's 8. 8. Just don't mind me. I'm just gonna sneak in behind you. It's like that guy in an elevator. You don't have enough room in the elevator, and the guy freaking like, I'll just sneak in. Like, no, you won't. Wait for the next one, dick. SN-22 was moved outside of the high bay and both aft flaps were mounted. Cool. Oops, let me just squeeze by you there. No, get out of here. I know about 2020. I know about that game, dude. Oh yeah. Oh yeah. Yeah, no, I had somebody tell me about it on stream before, dude, and I saw it and I'm like, oh no. Oh no. Oh no. Oh no, 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 no. I've been waiting on it 2020s because of waiting till it gets out of early access. Thanks for the earthworm, you dick. Railroads Online, Shrub. Looks like a B-1 F-35 thing. So, Rice, you're talking about the, Yeah, I know what you're talking about. So, how those things stabilize themselves, or how they yaw, is they have speed brakes that are built into the wings. So, like, if this is the wing, right, and the plane's going this way, the speed brake is like this. It can open up on both sides. And they use differential braking over the wings in lieu of a tail of a vertical stabilizer to yaw the plane. That's how they can do it. I mean, don't get me wrong, the planes are super susceptible to side slip, and they're not fighters by any means. They're drones. They just fly around and do surveillance and stuff, or at least that's what I would hope they do. They probably don't do that, but yeah, you if you're using a fighter, you generally want to have an aft vertical stabilizer. It makes the thing more maneuverable. But yeah, I know exactly what you're talking about. They have speed brakes on either wings outside of the ailerons or it could be part of the ailerons, and they could deploy like this. You deploy one, the plane's going to go this way. You deploy the other one, the plane's going to go that way. I know it's a tad late, but the car that hit the engine in the Xfinity race. Alright, I just want to see that real quick. Yep, and the radiator voided itself immediately, just like I said it did, and he mowed the lawn a little bit. Oh, oof. This guy's like, and you see, look at the dude's face. He's like, oh, all right. Yeah, Bandit, I think she's a little bit of a write-off. It'll buff right out. It's fine. A part hit Michael Jordan's motorhome. Yeah, right. That's what I've been hearing. Yeah. That guy, I love that guy's face. He's just like, yeah. No. No thanks. Yeah, winds took down a barrel section. That looks like you. It's not me, man. I'm here. I was here the entire time. Now, fortunately, Neo, car engines don't fly very well. Is that a sentence that just came out of my mouth? Fortunately. Okay. Get the Bondo out. They can just replace the shell, Fistus. You're not... NASCAR doesn't... At least, Bandit, clarify here. You're not limited on engines in NASCAR or shells or anything like that, like your chassis like in Formula 1. You just make another chassis, right? Yeah, Death, yeah, that's a good point. Yeah, Doom, yeah, there you go. Do you think boosted development is far from the final product? 8 is probably what closer to the final product. No, yeah, there's no restrictions on it. Engines are limited now. Oh, Rice, I'll tell you about the F-35 and what that thing is supposed to do. The F-35, dude... Okay, locusts, right? You know what locusts do? Swarm things? Yeah, the F-35 is designed to work with a drone called an MQ-58. And the drones swarm things. Yeah, you want a fighter drone? MQ-58, look it up. It's nuts. And the F-35 is the brains. There's a reason why that thing is so expensive. Let me put it to you like that. Is my green truck there? It is! The green truck is there! No, get out of the way. My green truck is there. See? See the OBS over there? Hell yeah. Yeah, literally a Protoss carrier, Buck. It can do that in real life. It's kind of scary. That's... What do you do? Like, what do you do? What do you do if you have that coming at you? How do you fight against that? Take out the F-35? Good luck. I see. See there. I didn't know there was a thing yet. Wingman drones. Yeah, there's a booster section right there. Here, I'll show you, dude. Check this out. XQ-58s. This is the new hotness, man. This thing, so they'll launch a bunch of these, and then these things will form up with an F-35. And then the F-35 can basically tell the drones what to do. Like, okay, you want to go over there? You want to dogfight against a bunch of people? Tell them to go over there and dogfight. And they will. Which is crazy. It's a Protoss carrier. It's a Protoss carrier from StarCraft. And, oh, they have JADO take off, too. I didn't know that. Look at that. Look at that. It's got some rockets on the back there. That's pretty neat. What are those scoops on the barrel? They're vent tubes, Scully. Yeah, no, if you guys ever watched a Protoss carrier in a StarCraft game, the F-35 with those Q-58s can literally do that. Yeah. That's kind of scary. Yeah, what do you do? What do you do against that? What do you do? How are you going to go against that if like 5 F-35s come at you and each one of them it has 20 of those drones? Oh, great. You shot one drone down. Yeah, good. 3 take its place. Dude, that's creepy stuff, man. Yeah, and I know what you mean. They've been cleaning the inside of this booster segment for a while now. There was a guy pressure washing it the other day. Now they're wiping it down. You see that? There's a taller ladder for a taller wall. Yeah, Hellfish. And if I saw that right, those MQ-58s look to be they look to be painted with radar absorbent material, so that means they're stealth as well. So, okay, kill the F-35, easy. Yeah, I know, right? And then then 3 F-35s takes its place, and then you have 100 drones swarming wherever you are. Nuts. Yeah, Shrub, possibly. Yeah. Kind of, Penta, yeah. Yeah, an EMP. I mean, the radar absorbent material might be EMP proof. I don't know for sure, though. I don't know what that stuff's made out of. I hate war stuff. Yeah, it is what it is, Malachi. I acknowledge the coolness of it. I don't like the reason why it exists, but I understand. I get it. I mean, I have to like it, right? You know? I mean, but on the other hand, that is really freaking cool, man. On the other hand, that's really neat. How does one EMP proof something? If you have something that's generating a magnetic field, Orange, so what? If you generate a powerful enough magnetic field, you can basically rad harden your whatever. I don't know if we do that. I know that's a way to do it. That comes from like what Earth does. Earth's magnetic field does that. But then again, it's not necessarily EMP, it's radiation. But then again, you know, it depends. Like, wait a minute. Are there multiple types of EMP? Or is it... There's got to be. Maybe I'm getting it confused. Faraday shields? Yeah. Yeah, Entropy. Walk softly and carry a big stick, man. There's nothing wrong with making cool toys. It's just, yeah. Prefer to not use those, am I right? Arctic 40 months, boyo. That's right, man. Oh. Tank leaves? Wait, it's leaving? Huh. Yeah, there you go, Sizzler. Yeah, the wide bay is taller, Raven Guard. I don't know how tall that thing's gonna be, dude. Wonder if that tank's headed for Florida. Maybe. Yeah, goalie, it is a little baby tank. Hey, Ouroboros, 15-month resub. Thanks, man. How've you been, dude? Hopefully keeping yourself busy. It's retired, Bryce. The F-14's gone, man, and it ain't coming back, which sucks. The only people that operate F-14s in the world is Iran right now. Could a full-stack Starship be moved? Goalie, I'm going to guess no. Probably not, because Starship needs the vehicle stabilization system for stacking purposes, right? So I'm going to guess no. It was followed by a SpaceX Crew transportation vehicle, so I'm guessing it might be moved to the gun range area they bought, which is used for storage right now. Yeah, okay. Have you seen Tiny Combat Arena? No, I don't know what that is. Airborne, it's not as busy as I want, but you're still hanging on. Yeah, I know. You got to keep on keeping on, man, right? You think SpaceX should build something bigger than the VAB for Starship? I think they should build what they need, DJ. Honest truth. Just build what you need. Hey. Notice the names. Ah, yeah, Golia. Notice those names, huh? Oh, that's cool, dude. Sweet. You're moving around the chopsticks. That booster has never flown, Jamie. No, nothing. None of this stuff has flown. The only thing that exists at Starbase nowadays that's flown is SN-15. Yeah, Katra, I did see it. Yeah. Get to the chopsticks. And Starhopper. That's true. Starhopper as well. Can't forget about Hoppy. You're right. mean, Doom, the pad isn't finished, so... The pad isn't finished just yet, so yeah, basically. I mean, they're just buttoning up the pad and getting it ready to go. Also, there's one of the pulleys right there for the crane, or for the chopsticks. See it right there? See the wire? There's another one on the other side, and the wire goes up the other side. Yep. Methane. Quick question. Is there any spaceflight hardware that use hydrogen peroxide nowadays? It's used in places in the aerospace industry, winter site. Yeah. High test peroxide? Yeah, it's used somewhere. Don't know where, but I know it's used. Yeah. See this thing right here? This thing is really cold. You can tell it's really cold because of the way it is. And that's pretty neat. That's the ice cream maker. Yep. Bro. Ho ho. Look at that. Is Methane near Methuen? Yeah. Yes. Yeah, look at that. GN2 is coming out of the booster. Oh, that's so cool, man. Look at all those motors in there. Gaseous nitrogen, Thaney. GN2. There's GN2 and then there's LN2. Well, it's not LN2 coming out of it because if there was, it'd be a liquid. It'd be pouring out. Because it's venting like that, it's gaseous nitrogen. How do I know it's nitrogen? Well, whatever test that they're running, they wouldn't do it with oxidizer. If they're using LOX, well, you could, but if that LOX finds anything that's even remotely flammable, and somehow that finds a source of ignition, the whole pad turns into a giant crater. So you probably wouldn't test with that. Simultaneously, it's probably not methane either, because venting methane into the atmosphere is very, very much frowned upon. So you probably wouldn't be testing with that. It's nitrogen. Thaney, I thought you said my name. Thaney. I did now. Hi, how you doing? Yeah, you vent too much methane. Like, don't get me wrong, you can vent a certain amount, but if you vent too much in the atmosphere, Captain Planet will come and kick you in the nuts. Figuratively. It's important distinction. EJ's one with the heart ring, Robot Chicken flashback. Ode to the nut shot. Classic. Alright, dudes. Well, that's pretty much all I got for you. I know that literally the Antares launch and Starship stuff is pretty much it. The news cycle for this week for space news has been kind of slow, which is why I've been talking about other things for space news. But, yep. Good dive into helicopters. That was fun. Captain Planet. Yeah, you like that? Can we do an Apollo test mission for fun? Did you cover the Aerojet news for the A1 engine? Yeah, Novus, I did it kind of in the middle of space news. When I was trying to get back on track. So it was the one of the startup thing. It's a piece of startup hardware. Wasn't working correctly. Any update on Astra? Cake, I've heard nothing. Yeah. I've heard nothing. Greatest space docufilm ever if you have the time to cover some incredible stuff. Oh, homemade documentaries. Yeah, that guy's cool, man. There's a TFR for the Kodiak area, which is believed to be for the next Astra launch, which is net February 28th. I mean, Novus, yeah, it illustrates the process. They took the thing off, and then they deemed it, you know, that they knew enough about the fault tree analysis, right, that replacing it would be okay. And then after that, they tested it, and they figured out what made the fault, and then they went back and checked the other engines, and they figured out that they weren't susceptible to the same thing. It sounds like just a bad piece of kit, to be honest with you. Yeah, the computer chip just took a dump. It do be like that sometimes. It's good fault tree analysis by NASA. I mean, when is it not? They invented how to do that, you know? Oh, hey, Kyle posted some pictures. Kyle Montgomery posted some pictures of the Antares launch. You guys might dig him. Yeah. Kyle, these are. Yeah, I'm gonna go ahead and. Yeah, Spoop. You know what the funny thing about that? The engines that are doing that, that's real. That's a real picture. Elon just took his phone and, well, the booster was on the mount and just took a video of the engines just doing this. And then I made it into a repeatable GIF. What's the plan for KSP tonight? I don't know. Maybe I'll mess with helicopters. Also, Rocket Lab is on the 27th, which is a Sunday. Yeah, of course it is. Yep, that's a pretty good shot by Kyle here. Guys, if you want to see more of Kyle's photos here, check it out. What are some of the benefits of having a solid fuel? What are some of the benefits of having a solid fuel upper stage? Seems a bit risky. Why does it seem a bit risky, Jax? Or let me put it this way. Why do you think that's risky? Yeah, DJ, most likely, which sucks. The people that filed that lawsuit suck. So uncool. I don't understand why. Yeah, I know. So, Jax, the whole can't turn it off thing, unless you're Northrop Grumman and you're geniuses. Solid rocket boosters, believe it or not, are very simple. They have, if you have thrust vectoring with an SRB has two moving parts. Well, three. X-axis gimbal, Y-axis gimbal, and then the igniter, and that's it. 3 moving parts. Yeah, you run the risk of, not being able to shut it off. But if it shuts off, that means you didn't make it into space. So, it's not, I mean, if that's the case with any upper stage, to be honest, when second stage is on ascent, if it shuts off at any time except when you accept at SECO, you're pretty boned anyway. So, I mean, it's the simplicity is the reason why they do it. It's very easy to make it. It's very simple to make, comparatively to a liquid fuel engine. SpaceX got 2 little boats, one for each fairing fisher. Let me see. Yeah, they got little dinghies. Quit playing with your dinghy. Front end of the car that hit the engine. Yeah. Hellfish, somebody linked that picture. See how it croaked the radiator? Hey, Nazalik. You can adjust the second stage burn depending on first stage performance, though. Why? Why can't you do that? Of course you can. You saw it happen today. If you saw the Antares launch. What are you talking about? Of course you can. Always another way. If you can't turn it off. Well, you didn't. Oh. So, the SRB is always designed to overperform a little bit. Not by much, but just by a little bit. And that's your margin. And of course, there's a margin it gets to the point where like maybe burning for an extra like 3 or 4 seconds where, yeah, that's where you're not getting into space, right? So what Antares does is when they're basically what they can do to compensate it. So once again, you can't throttle it, you can't shut it off, etc., etc. You can't make it burn for a little bit longer. But the SRB is automatically designed to burn a little bit longer than what they need. What they do is they incorporate that into the flight trajectory. So what do you mean incorporate that into the flight trajectory? The SRB puts itself, it burns with prograde velocity, right? So you want to accelerate. When they've reached the speed more or less that they want to get at, what the SRB does is it turns down, and Antares Cygnus with that Castor 30 burns radial in. They burn radial in. And that's basically using up the extra fuel. It takes more delta V to do a radial in burn, right? We know that from KSP. That's how they throttle it. You can get the exact trajectory that you want by basically going too fast, overshooting, and then burning radial in, and it adjusts your trajectory exactly to where you want to. That's Antares' fallback redundancy, just in case the first stage underperforms or whatever. What's the lawsuit? I don't understand it, DJ, to be honest. Yeah, they can waste delta V by burning radial in. Hypersonic. So yeah, Antares is actually a little more redundant than you might think. Yeah, it's more, that single SRB in the second stage is pretty damn reliable. You know it's going to turn on. I mean, well, with good testing it'll turn on, but you know that it's going to work. And yeah, the thing has RCS on it, and it can adjust. It'll burn radial in or radial out to basically throttle the booster, so they can get precise insertion. It's not, guys. SRBs aren't as bad as everybody, that knows a little bit about space flight, knows about the space shuttle, and knows about segmented SRB O-ring casings and stuff. Like, segmented SRB casings and O-rings that connect them together, etc., from Challenger. But the reality of the situation is that SRBs are pretty damn reliable. And I can use the shuttle program as an example of why they're so freaking reliable. Because every shuttle launch post-Challenger, the SRBs never underperformed. They always worked as intended from there on out, which, once again, feeds into a point that I have about the space shuttle, that the design wasn't a bad design, it just wasn't tested enough. And the thing is that you can mechanically program, I wouldn't say mechanically, that's not really the right word. You can program SRBs to throttle down. They did that with the space shuttle. The SRBs throttle down. They tail off and then they regain thrust. The reason how you program that is by setting the SRB combustion chamber geometry, okay? So the SRB is a ring, and that ring has grain packed along the edges of the ring, and the grain is in like a torus shape, and then there's a little hole in the center. When you light it, the grain ignites, and it gets shot down the center hole to the throat, out the nozzle, right? It's an Estes rocket motor. It's a big Estes rocket motor. That's all. How you physically pack the grain inside of it can make you can change the combustion chamber geometry variably. And you can actually program the thrust. So you can't throttle it in real time, but you can program it. The grain is the industry term for solid rocket propellant. So here, take a look. You can program the SRB to do different things. So this one, what I'm describing here, that's just a toroidal grain pack. That is called a progressive thrust curve because it burns radial out. So it starts burning this, and as that circle in the center gets bigger and bigger and bigger, you're increasing your combustion chamber surface area. With a rocket engine, if you increase your combustion chamber surface area, you make more thrust. So it's a variable geometry combustion chamber because the SRB grain is making the combustion chamber when the SRB is on. This is what an Estes rocket engine does. So you can have a progressive thrust curve. You can have a static thrust curve like this. Basically, if you pack the grain in a ring like this grain burns in, that grain burns out, your geometry stays static. So you have a static thrust curve. With the star right there, you have a slight, well, you have like, that's like a, I don't know, parabolic thrust curve, I guess. And then when these points right here, if it burns to the end of the point, it just makes a circle, and that's what that tail off right there is. This is a static regressive thrust curve. That's a, I don't know why you would need this. I don't know what that one is called. I have no idea. And this is a regressive thrust curve, the boat anchor. The Space Shuttle's SRBs use something that's like halfway between 3 and 6. But here's the thing. The Space Shuttle SRBs are segmented solid rocket boosters. Each segment doesn't have to be the same shape. Say the shuttle used 4 segment, right? So you could have segment 1 like this, segment 2 like that, segment 3 like that, segment 4 like that. And it'll get you a thrust curve that throttles up and down and up and down and up and down. That's how they got the SRBs to throttle themselves during max Q. The SRBs throttle down as well. They tail off. That's what it's called. It's called the tail off thrust. It's called tail off thrust, like this. But see, because you have segmented SRBs, you can, and the grain burns from the top down, right? It burns from the first segment. The igniter's up at the first segment, and it burns down, like how liquid fuel drains out of the tank. Same idea. Each segment can have a different shape, and if each segment has a different shape, you can make the SRB throttle up at liftoff, throttle down for max Q, throttle back up, and tail off again. You can have a sinusoidal thrust curve. Do all 4 segments burn at the same time, though? Yeah, for the most part. Yeah, they're all burning at the same time, but the grain burns from the top kind of down. It's burning down and it's burning out at the same time. It's hard to explain because the igniter is at the top and the gases are getting shot down through the center of the grain. So you start burning at the top, but you also burn out at the same time. Yeah, it's weird, dude. SRBs are weird. It's a rocket engine with a variable geometry combustion chamber. Very interesting stuff. Of course, Fleicken. Duh. So it's a physical change that has to be planned beforehand, not an, oh, we need to throttle down right now type thing. Correct. It's programmed. Mechanically, though, with how you physically put the propellant inside of the grain inside of the SRB. Do you happen to know if they had differently packed SRBs for different shuttle missions? I'm pretty sure, Bright, it was the same every time. I want to say it was the same every time. Not because I have a source for that, but because, well, why would they do that? Okay, so what would constitute... Why would you want to, say, have more thrust at liftoff? Right? Why would you do that? Well, why would you want? Maybe a heavier payload? Well, the shuttle's TWR off the pad with 25 tons in the payload bay is still 1.4, so why would you need more thrust? I can't think of a discernible reason. I can't discern a reason why you would want to do that. I don't know. But I don't know for sure. I don't think so. I think they were packed the same way every time. I'll bet you money that SLSs are packed the same way as well. Cool explanation of SRBs. Thanks for that. Yeah, sure, George. Yeah, no problem. Now, the cool thing is, if you guys really want to do something cool in Kerbal, you can do this in KSP. How? Well, the cal controllers. If you take the thrust limiter and you take the burn time for the SRB and set the cal controller to the burn time of the SRB, say the SRB burns for 100 seconds, you take the cal controller, set the cal controller to 100 seconds, and then key in the thrust limiter icon, and then make the thrust go up and down and up and down and up and down, you can program the thrust on your SRB. Basically, when you activate the SRB, have an action group that activates the cal controller at the same time. And you can make progressive and regressive thrust curves if you really know what you're doing. My Jebstone launch vehicle had a regressive thrust curve programmed in. It had that, and it also had a throttle down for max Q programmed into it. The SRB, because it was the first stage, it throttled down for max Q so the vehicle wouldn't flip over. Just like Ares 1. Ares 1 did the same thing. And then there was a regressive thrust curve to make sure that the induced pogo from engine cutoff in Kerbal didn't wobble like the second stage and payload around. Yeah, I just looked at the wiki and the thrust curve is crazy. Yeah, the Space Shuttle SRBs, and that's the benefit of a segmented SRB. You can do that. It's harder to do with a single casing SRB, but you still can. Induced. Man, it's almost 10 o'clock. Dude, that was a fun like science news space technology thingamajigger. I like doing that. That was fun. I can do deeper dives into SRBs if you want. We can do stuff like that, dude. You just got to tell me. Or just ask the question. An Atlas's 5 motors are angled to keep the thrust through the center of mass. They have what's called a canted nozzle, T-Man. So the SRB nozzle is pointed out, but the SRB is still attached to the side. The nozzle just points out. Point through the center of mass. Thanks for the news and the info. No problem, dudes. Railroads online, Kuro. Bring back Officer Bremo. How about no? Crazy Dutch bastard. Straight into GTA? Well, I was going to play some KSP for a little bit, but, I mean, if you guys want, I mean... Alright. I'm not trying to start this conversation. Look at this. Look. What do I want? I don't want to know. You know what? I don't want to know. I don't want to know. What the You know what? I don't want to know. I'm serious. I don't want to know. Don't say. Just look at the hashtag and just. I don't want to know. Leave me out. Nope. That's. All right. Nope. Next news. It's KSP time. What the frick? I don't want to know. Here. Let's go play around with some helicopters.